Welcome. This is where your journey begins. Take a selfie and save it with the title, My Last Day Without Knowing Anything About Python, because learning is a one-way trip. My name is Phil Ebener, and I will be your partner in this adventure. I am convinced that without fun, there is no learning. So we are going to face this journey as friends who have a great time working together. Before we start, we are going to ask you to take a few minutes so we can show you how your path is going to be during the next few days. Today, on day 1, you're going to learn some of the Python philosophy. You're going to install all the software needed for the rest of the course, and you're going to learn your first commands, the basic ones, which are enough for you to be able to write your very first program at the end of this day. From tomorrow until day 6, you will go through the basic training phase. These days are going to play a key role in your development because you are going to learn the basics of Python, which is what every programmer should know. Everything you learn in the future will be based on what you learn during your first few days. On day 7, you are going to enter the advanced phase. You're going to understand the philosophy of object-oriented programming, which spearheads all modern programming and allows us to have all the Python resources to create agile, robust, economical, and repeatable and easy to maintain programs. At the end of day 10 of this intensive training, you will be ready to be a Python programmer because you will know everything an up-to-date programmer knows, and you will have accumulated many hours of real-world practice. You will only lack experience that comes with time. From day 11 onwards, the expert phase will start. When you get there, you will already be a Python programmer, and it will be the time to get to know its main applications in the real world. Each day, you will delve into areas of development such as machine learning, social network integration, blockchain, and much, much more. I remind you that this course is strongly based on real-world practice. Each day, you will complete it by creating a full program from scratch, and all lessons will be accompanied by 3 practical code exercises and a downloadable document with a summary of the topic. As a result, you can store all this in writing and have everything you have learned nearby in order to build your own Python manual. On top of that, each video includes a theoretical introduction and a practical demonstration. Additionally, at the end of each day, you will have a quiz to review and reinforce everything you've learned. It's a time to reflect, summarize, and celebrate some of your achievements each day. We are so ready. All this amazing content is waiting for you to start on the next lecture. Are you ready? Then hit that play button to go to the next lecture right now. I know you're eager to start programming, but just give me a minute so I can explain why Python is the best programming language you can learn, and how we're going to make it super easy for you to learn in this class. The main advantage is that Python is classified as a high-level language, and this means that its instructions are close as possible to human language, which makes it easier to learn and ideal for people who are just starting out in the world of programming. However, just because it is easier to learn does not mean that it is less powerful. Quite the opposite. In Python, you can perform tasks with a few lines of code, while in other programming languages, this would take hundreds of lines. This enables your productivity to go up. On the other hand, it is one of the most versatile programming languages that exists and can be used in a variety of fields. In other words, it allows you to program from video games to websites and mobile applications and much, much more. In addition to all this, there is a large community behind Python, which means that there are a multitude of libraries, this would mean blocks of codes, that are available for you to use in your programs to do almost anything. This means you can take them and solve more complex issues that are not relevant to your project. You simply use the libraries and move on. As I told you, Python was created to make its code readable, to be as close as possible to the human language. That's why I will help you learn it smoothly and to make it feel natural, like having a daily conversation, but with your machine. Then, writing or reading Python will be something super logical and understandable for you at the end of this course. I hope you are ready and as motivated as I am, because in the next few minutes, you will actually begin programming. Every day throughout this course, you will end up creating a program that can be applied in real life. And this first day will be no exception. You are going to create a program that will help a user create a clever and original name for a beer brand. Well, actually, it could be used to create a brand name for any kind of product, but we are going to think about a name for beer just for now. Keep in mind, however, the first programs you create, like today, will not be super flashy with a nice interface. Until we get more coding skills, the outcome of your first programs will be pure code on a black screen that returns a cold and dry result. As you advance, you will be adding functionalities so that your programs are effective as well as attractive. To learn how to program the goal we have set today, you must first do a few things, such as installing Python on your computer, installing PyCharm, which is the software we will use to work with Python. And to create the first program, you need to learn a set of tools like the print statement, strings, concatenation, and the input function. I'll be waiting for you in the next lesson so that we can get started together. For this lesson, we are going to install the software you need to write your code. And remember, Python is a language, like English or Spanish, so you can write it anywhere, in a notebook, on a whiteboard, on a computer, on a wall, and it's always going to be the same language. In the same way, there is a wide variety of applications for writing Python code, and each one offers advantages and disadvantages. We call these applications IDEs, which stands for Integrated Development Environment. So these applications are virtual environments that integrate all of Python's functionalities so that you can develop code in them. Because actually, if you want, you can write your code in a simple notepad and it would still be Python. But a good IDE does things like assisting you with code structure, helping you to detect, resolve, and debug errors, running simulations, and more. In other words, a good IDE makes your life as a programmer much easier. So it's time to choose one. We have to. And there are so many options. I don't want to decide for you, but I am going to give you my recommendation on which IDE to use to learn Python in this course, since it is also the one we are going to be using throughout the course on screen, and it's called PyCharm. We use it because it's powerful. Its interface is simple, its help system is very clear and complete, and well, because it's the one we actually have to use in real life. But before you install PyCharm, you need to install Python on your computer. I'll leave you in Federico's hands, who will guide you throughout this process. So let's go and do that.
Thank you, Phil, and that's exactly what we're going to do. We're going to install both Python and PyCharm on your computer, and we're going to do it all together so there won't be any problems. The first thing you're going to do is go to the python.org site, where you have all the documentation, the software, and much more. It's the official Python site. Of course, at the time you log in, it may look a little different than it does in my case. This is always being updated, so don't worry. But you will surely find a link that says download, in which you will find that the system recognizes your operating system. In my case, Windows. And here I have the newest, most current version that exists on Python so far. You may see a newer version. So let's click here to start the download, which is already being done on my system. What I do is click here to bring up the runner. We click on run and I've got some options here. The first thing we're going to do in this window is make sure that the Add Python 3.1 checkbox is checked to the path. So we're going to click here and then Install Now. And we're going to then start installing it. So as you can see, it's done very quickly. It takes practically nothing, and in a couple of seconds we already have all the code and all the libraries and all the stuff we need so that a computer can understand the Python language. So a few seconds more and we have it ready. And so we get to this window that tells us that the installation has been successful. It may appear below in this blank space here a warning that allows you to choose if you want to disable path length limit. If that appears, please enable it, and then you are ready to hit finish here. And now I've installed Python on my computer. If you are a Mac user, don't worry, the process will be quite similar to this one. Quite intuitive to follow, and you won't have any complications. If you do have any questions, please leave them for me in the Q&A area. So now we're going to install PyCharm. We're going to go to the Google page to search for it here. Note that we are going to do it now is install the software or IDE that we are going to use throughout the program as an interface to program with Python. Here you will simply search for PyCharm, and surely the first option that will appear is this, PyCharm, the Python IDE for developers. You can come here or directly to download PyCharm, and it will take us to the official PyCharm site. It is coming here. Note that I'll also leave this link for you in the lecture resources if you want to access it directly from there. And here we have two options to install, either the professional version or the community version. We're going to choose the community, which on the one hand is free and has everything we need to work with Python at a high level. Professional has some more features, it has cost. You can try it for free and see if it works for you, but to start working with Python and start learning it, with the community you'll be more than satisfied. A few more things on this site before we move on to what's next is that you can see the system requirements here. You must meet all these for PyCharm to work well on your computer. The installation instructions, which is basically download it and run it and nothing else. So let's go here to download. And here it starts to install the PyCharm installation runner on my computer. And once it's done downloading, we can click on the installer. So this is going to start the installer running. We actually choose run, and this is going to be pretty intuitive and easy to follow. We choose next, then we leave the default path, or choose another one if you want. I recommend to leave this one. So we go to next, and here the only thing we can add if we want is the desktop icon. We click here and nothing else. The rest, check it, but I would leave it as it is. We do next, then install, and now, yes, in a few minutes we have PyCharm installed. And once this software has been installed on your computer, this window appears confirming it. So you can click here to run it now, but let's show you how to open it. It's very simple. We do finish, and then now you can look for the icon on your desktop, or come to the Windows system icon. You will find here PyCharm Community Edition. We click on it and it will open for the first time as we run this program. The first time it will ask us if we're going to import the PyCharm settings. We're going to leave it in do not import, so that it opens as it comes by default. And this will be the welcome screen where I'm going to change something before we continue, which is going to be the customize and personalize. So here you can choose what kind of interface you want in terms of color scheme. And dark colour is perhaps the nicest because it's dark. It allows your eyes to be relaxed and not disturbed by the garish colours. We also have this combination which is whiter, brighter. But it may not be the most pleasant to work with at night especially, but during the course I'm going to use this high contrast one. While it's not the nicest of them all, but because it's quite garish, I think it's the one that is the best contrast to show you all the functions and text on the screen as I work on my computer. So I recommend dark colour, but you can choose any option you like. So here you can increase the font size of our software, not the text of the code. We will see that later. But if I set, for example, 18, this enlarges the whole size in which you can see the letters. I think this is a bit too much. I'm going to leave it at 14. For my taste, it's going to be fine. And you have more options here, but with this, to start with, it's going to be fine. We can go to projects. Then here you are going to choose if you're going to work with a new project or if you're going to see a project that you've already started. I'm going to show you how to create a new project in this lecture, so you'll be able to start in the next lecture. So we click on the plus, and then when we come to this, the first screen, which is the one you'll see whenever you want to create a new project. And a project is going to have a lot of Python files because you can create a lot of code which interacts with each other, and then you decide where you're going to save that project. By default, here it gives you a path. I'm going to work with a folder that I'm going to create on my desktop, directly to work much more comfortably there. So we open my computer, we're going to go to desktop, and this is where I'm going to create my folder. Of course, I'm going to name it because right now my folder doesn't exist yet. We do it with the backslash, and we're going to name it Python. Nothing more than that. You can leave the rest as it is to start with. You'll learn later what each of these options is for. But for starters, we're good to go. So we're going to click Create, and this is then we're going to take us to the first run of our software. You may get a message from Windows Defender at this point that says something like this regarding your computer's security. You can click directly on Fix, and that will resolve it. It's fine. It doesn't appear to me because I have already installed the software before. Like many softwares, this one also starts with the tip of the day. It's not really something I pay much interest to, so I'm going to ask you to stop showing me these tips and close and move on to running our first instance of PyCharm. So, and here we are in PyCharm, the proper PyCharm. I'm going to maximize it, and I'm going to ask you not to panic if it looks too complex what you're seeing. We're going to get to know this interface step by step as the course progresses. We're going to go from simple to complex, and you're going to master it without any fear. We're going to close this file that we have here that's called main, which is a class that's generated by default. So you'll see this a little bit less overloaded. Our interface has a column here where we're going to be looking at some options. This can be hidden or shown again because it's not the core of our work. Everything important is going to happen in this larger area here, which is where we're going to write our code. The rest are all tools for working on our code. So we're going to concentrate on this area primarily. We're going to learn what's here in the menu bar. We're going to learn some tools here that are very important. But for now, we're just going to stick with what we've opened in PyCharm, and we're going to create our first file inside the project that we've named Python, which is the folder that I created, remember? And here it is. So if I right click here, I have the option to choose New File. If I choose New File here, I have to name it. And I can name it, for example, First Project. But I'll show you what's going to happen. When I hit Accept here with Enter, it's going to ask me to choose what kind of language it is that I want to have in this file. And I want it to be Python. So I can come here and choose Python and then start working here. So I have that option, and I have my first choice here. Open matching files in PyCharm. And then Python. But we're going to make it easier so you don't get too complicated. We're actually going to come to Python. Right click New File. We could choose Python file here, and this would also save us that step. It opens a Python file directly. But if we put file as just now, and I want to put first project, so that it doesn't ask me later what kind of file I want, I just put .py. By putting it this way, I'm already telling it that I want to work with the Python language. We hit enter, and here is our first project created, with the first line ready and the cursor blinking for me to start typing. Are you looking forward to it? In the next lecture, we're going to start writing code. So thank you very much, and now we'll see you in the next lecture.
Finally, it's time to start writing, and we're going to start by learning how to use print, one of the most basic and common statements in Python. When we say print in Python, we don't mean print like on paper using a printer. We mean print on the screen. So print actually means to show, to display on the screen. And as I told you before, Python is a very simple language to understand. So if we want Python to display or print on a screen, a sentence like hello world, for example, we just say print hello world. As you can see, the print structure is very simple. The keyword print, and then we put in parentheses whatever we want to print. If it is text, it will go between quotation marks. And there can be double or single quotation marks. It doesn't matter. If they are numbers or other functions, then we do it without quotation marks. But don't worry about that because we are going to deal with this later. For now, let's go to PyCharm with Federico so that we can learn together how to use the word print to write your first text.
And so, it's time to write our first line of code. We are in PyCharm, we have our space here to write. We're going to enlarge it by clicking here in Project, so that this column folds out and we can see more clearly our space to write code. We're going to begin to use the statement print, so we write it directly. After typing print, here you can see that we get a help that tells us that print is followed by the bracket signs, and inside we can put values. These helpers are very useful. It shows them for PyCharm all the time. If you come to the points and click, you will see that you can sort by name, but the most important thing is that you have a quick documentation or a quick definition, and these are very useful when you're working with code that is starting to get a little bit complicated. But for now, let's stick with print. We're going to open the brackets, and we said that we are going to write a text. We're going to write with quotation marks whatever is inside. And what we are going to put here is the expression hello world. With this, it will be enough so that when we execute it, we can see that hello world is printed on the screen. But first I want you to notice the colours. As you can see, print is written in blue because it is a key word. Then the brackets appear in a different colour so you can easily identify when the content of print begins and ends. And the content, the text we have entered, is in green. Then what follows is to run this program to see what appears in console. To run it, we're going to come here to run. And it gives us a choice whether which file we want to run. Main was the file that appeared at the beginning, which is generated automatically. It is not the one we want to run. The one we want to run is first project. So once we choose it, the console appears here and it shows us the path of this file. Then the result of the execution of our program that shows us hello world. And here it simply says that it has finished executing the code. So it has already exited the execution. It's very simple. It only has one command. It says hello world. So I want you to notice what happens if I change something with respect to the quotation marks. Let's say I remove the last quotation mark. In that case, you can see now that everything is green and it marks a serious error. This time it is in red because not having told Python when the text ended, it thought that the brackets were part of the text and included it. So there it is marking an error. It is normal that this can happen frequently, or that you forget the brackets. For example, it will also warn you and that you would be the most common of errors for this type of text. In fact, if we want to execute it without the quotation marks, let's suppose that we have not seen the error that announces us, and we go to execute. This time we can do it from here because first project has already been loaded and we can click here on run. Well, the result now is no longer hello world. It is a syntax error. This is how you're going to read the errors when they appear. You're going to see what kind of error you have, and we can actually see in the example of our text that is marking us here that this up arrow, where the error is apparently located. So PyCharm is quite clever at helping us solve our code problems. So we return the quotes and now our code is back to normal. Note that in print you can write whatever you want. And some considerations, if you wanted to write something with quotes, for example, hello world, I say hello. And I want to put it like that, with quotes. Well, what problem am I going to have here? That when I want a quotation mark to appear in my text, unfortunately Python is going to misinterpret these quotation marks and it's going to think that I'm ending the text here. And that I start again here and this hello doesn't understand it. It marks it as an error. It's not a word that Python understands. So when you want to put quotation marks inside your text, we can use single quotation marks and Python will differentiate from the double quotation marks and understand that they are simply part of the text. You can also do it the other way around. Put single quotes outside and double quotes inside. For text interpretation purposes, it is the same thing. So if I run this now, you'll see that it says, "Hello world, I say hello." Print, as I explained, can print not only text, but also numbers, and here I can put 100 if I run it. What will come out here is the number 100. And the numbers do not need quotation marks. It will print them as they are. You can also actually print operations. If I put in 100 plus 50 and run this, that's going to come out here as 150. If I wanted the operation to show, I could have put quotation marks at the beginning, quotation marks at the end, show it as text, and then we see 100 plus 50, and not the result. When you put numbers without the quotation marks, directly what print does is to execute the operation that it finds inside. This is all to start with working with print. So I thank you again for joining us in this lecture, and we will learn a little bit more about this in the next.
Welcome to the strings lecture. In the previous lecture, we learned how to print data on the screen using the print statement. And as we saw, we can use it for any kind of information: numbers, text, variables, and many more things. But let's not get ahead of ourselves. You have seen only text and numbers so far. In Python, there are many types of data, and we will see them throughout this course. But let's start with the data known as string, which is nothing more than text strings. That's what we'll focus on in this lesson. They are called text strings because in reality, a string is a string of characters. For example, the word hello is a string composed by the letters H, E, L, L, and O. And this is important since it is how Python is going to process our text. That's why we use quotation marks every time we write a string, to clearly inform where our string starts and ends. Another important feature is that strings can contain not only letters, but also numbers or special characters. But even so, everything in a string will be considered as text. White spaces, special signs, punctuation, and even mathematical operators and numbers. While they're inside the quotes, they will not be treated mathematically, and you will not be able to do operations with them, since they will be treated as text characters. I say right now you follow Federico, head over to PyCharm, and learn in a little bit more depth.
And here we are again in PyCharm to see how strings work. We have already seen that a string is a text string enclosed in quotes. We can put it inside of print to print or display on the screen a certain text. As I explained a few seconds ago, what we have here, although they are numbers and there is a plus sign, and you might think that this is an operation, this is actually a string because it is in quotes and therefore the console does not interpret it as an operation. And the result it gives us is not 150, it gives us the expression 100 plus 50. Remember that we would have to remove the quotation marks so that it actually returns a numerical operation. But let's continue with the strings. Strings can not only be described as a sequence of characters, as we've seen so far, but also several sequences of characters, and put them together or join them in what we call a concatenation. So here I'm going to type Fedi, for example. I'm going to execute this. And here we see in the console that it says Fedi. And this is very simple, but I could add here before another expression that says hello. We close the quotation marks, we put a plus between both expressions, both are with different quotation marks, the first with double, the second with single quotation mark, this doesn't matter, and observe what is going to happen if we execute this. What you see is that it says hello Fedi, but it actually says it all together, because if we look back up here to the print, I've joined two strings, but I haven't left any space in between them. I could solve this in three different ways. I could put a space here, and this, if we correct it, is going to say hello space Freddy. We could also remove this space and put a space before the F in the second string, and this is going to work the same, as it still displays hello Freddy. Or you could generate a space by creating a third string with nothing but an empty space. I'm getting an error here because there are 2 quotation marks. Okay, problem solved. And we have then a string that says hello, that is concentrated with a string that is empty, that has, well actually it's not empty, it has a blank space. And a third string that even though it has different quotes, it's going to be taken as a string anyway, and it says Freddy. Also, if we execute this, we will have our hello Freddy, which works exactly the same as the other 2 previous ways. So some other considerations for when you use the strings. I already showed you that if you want to show quotes inside a string, you do it by putting different quotation marks than the ones you've used to wrap that string. But there is also another alternative. Let's write here another phrase like my name is Federico. That's it. Let's leave it like that. So it's giving me an error because I start with double quotes and end with single quotes. There, now that's corrected, and well, my name is Federico. Plus the closing brackets, and I might want to put Federico between quotes. I showed you that here I can solve it by putting single quotes, and that would solve it. But also if I wanted to put double quotes and use the double quotes outside, I have a special character which is the backslash. When you put a backslash, you are telling the code that the following character is not going to be taken as a character, but it is a special function or a textual character. So if I put double quotes here, Python paints it in a different colour, I want Federico to also end with the double quotes, so I put another backslash and then the quotes. So if I run this, I want you to observe how it looks in the console. My name is Federico, in double quotes. So the backslash tells Python, hey, the next character, don't take it as text, please take it as a special character. It can be to make it textual, as in this case, or for other functions like the ones I'm going to show you now. So we're going to delete all this, and we're going to put quotation marks, and we're going to say here, this is the one line, and this is another. You will say, that's bad writing, Freddy. We put everything in a row without leaving a space. So I want to show you how to write 2 lines in a row with the same print command. So let's put here the backslash, and then the letter N. The N is a special character that says new line. Then Python, when it reads this, will understand that it must insert a new line. Let's execute it and see that here we have. This is a line and this is another line, although it is all in one print. We could also continue writing if it's another different option, another command print below to which I'm going to put this is the third line. Between quotation marks, we execute it and it works in the same way. I can put this command in a separate print or with a backslash and N to require the Python compiler to generate a new line. Another character we can incorporate is the backslash with the letter T. The T stands for tabular. That is, adding a 4-character space before the next character. If I run this, we will see that this is the third line is separated by an indent, by a 4-character space, which is nothing more than if I had pressed the tab key. So, do we have any more options? Yes. We also have the possibility that when we want to write something, let's suppose I want to write, let's delete all this, let's open parentheses, let's write this text with single quotation marks, and I would like to put something with an apostrophe. For example, this isn't a number. And what happens? Isn't should have an apostrophe between the N and the T, which is written with the single quotation mark. But here's the problem. When I put the single quotation mark, having a single quotation mark is enclosing this text. Python said, you're ending the first text string. I don't understand this, and I don't know anything more. And that will give you an error. So then we also have the possibility of using, well, either putting double quotes outside and that solves it, or putting a backslash before the apostrophe. So remember, here we're telling Python the next character takes it as it is. It then understands that it is an apostrophe, which it should read as such, and that is not the enclosing quotation mark. So we executed, and this isn't a number was spelt correctly. One last lecture about the backslash is that sometimes you may want to write the following. This sign, the backslash, is a backslash. What if I want a backslash to appear in my text? Here I'm having an error because the backslash is an escape sign. Then Python will execute it in a very strange way. If we want a backslash to appear, what we have to do is after the backslash, type another backslash. So we're telling it the next character, that to this, the second slash, take it verbatim as is. So let's run this and see what we're going to see is this sign is an invaded slash. Many times you may need the slash to be part of your text. So thank you very much for joining me in this lecture about strings, and see you in the next one to continue learning much more.
Welcome to the lecture about the input function. So far, we have learned that we as programmers can display our information on the screen thanks to the print statement. But what if we want the end user of the program we are going to create to be able to enter their own information? There is a function to ask the user to type something and then be able to display that information or store it to do something with it. For example, if we want to ask for the user's name, we say, input your name. So the input structure is very simple. The keyword input, and then the explanation or request in parentheses, so that the user understands what he or she is expected to enter. This explanation must be in quotation marks, double or single, it doesn't matter. Hence, this responds to all characteristics of a string that we have learned in the previous lesson. And what is the system going to do with the information entered by the user? For now, it is going to retain it so that we can do something with it. In the next lectures, we will learn how to store this information to use it as we please later. However, in this lecture, we are going to learn how to print that information on the screen. How? Enclosing this input statement inside the print statement. Do you remember I told you that print can print not only text and numbers, but also functions? Well, what we are saying now is, please Python, print what the user enters after asking for his or her name. How about we go to PyCharm right now to see this in action?
So here we are in PyCharm, and we're going to start testing this input function. We're going to eliminate what we've had from before, and I'm going to show you first how it would work with print. So if I ask someone for their first name and then their last name, for example, I can put print. So we open the brackets and then we open the quotation marks, tell me your name. I'm going to put a colon and then a space so that the cursor is blinking one space away from the colon. Let's create the other line right here. Print, open the brackets and the quotation marks, tell me your last name, and also the colon, and leave it there. If I run this, I'm going to show you that also to make it faster you don't need to go to the green triangle that we have here, or to the run and search, but we also have the keyboard shortcut Shift and F10. So we're going to do that. We're going to press Shift and F10 on the keyboard, and this makes it run automatically. And this just prints, tell me your name, tell me your last name. And here it says that the execution of our code is finished. In other words, I'm no longer in the code. If I want to write something here, I cannot. I'm trying to do it, and if it is not possible because the code has finished. How is this going to change when I write the input function here? So let's put it in both. Input, here as well. Now I have two input functions that, as you can see, what we put inside the brackets is the prompt. That is, a title that tells us the user what to type. So let's run this with Shift and F10, and notice that the difference is now it says, tell me your name. The system has not executed the end of the code. it hasn't even shown me the second line, the one that says tell me your last name, because now it's waiting for the user to do something, unlike print, which doesn't wait for the user to do anything. So I click here and I'm going to say my name is Federico. We hit enter. Then it asks for my last name. My last name is Garay. And when I hit enter, then the code ends. The system waits for me to do something and does not execute the following lines because input waits for an input, and this is very important to understand. Now, I've already entered my name, and what did the system do with it? It basically forgot it. It didn't do anything. If I now wanted the system to know my first name or my last name, it doesn't know it because it hasn't finished the function, and it doesn't store it anywhere, and it didn't show it on the screen. Here what we see on the screen is what I entered, but not what the system has. Well, one way to do this would be to incorporate it inside a print statement. So, if I enclose all of this inside print, as we saw in the explanation at the beginning of this lecture, we're going to put print here. We're going to select the whole input function and we're going to press the opening brackets, and this automatically creates the closing brackets as well. Observe what is going to happen now. If I run this, it says tell me your name. I'm going to put here Federico. I hit enter, and after it appeared here as I wrote it, it showed it on the screen. Why? That's because it executed in the order from the inside out. First the input, and once I entered it, then I continued typing the print, and it printed whatever I typed. And this is one way of displaying it. If I want to display a sentence with my name on it, can I do that? Well, remember that we can concatenate inside print. Then I can put here that what print says is, in quotes, your name is. I leave a space, close the quotes, put the plus to concatenate, and what follows is the input. And this input doesn't need quotes, so the idea is that I can form a sentence here with what the user enters, so we run that as well. It says, tell me your name. I write it. Your name is Federico. The sequence of concatenations that included both a text and a function was completely executed. I would also like to tell you my last name. Then I put, your name is. Let's put another concatenation here. I want a space to be generated. So I open the quotation marks and leave a blank space inside so that there is a separation between the first name and the last name. Now I'm going to ask for the last name. Input, and in the brackets and in quotes, tell me your last name, the colon and the space. And watch before we run this and try to imagine what's going to appear here. We have a print command, so we tell it, please print the following expression, your name is. Then please continue printing, concatenating that with a user input, which is going to be what the user responds to when we ask, tell me your name. So that concatenates please with a space, a single space. Then please concatenate with another user input that's going to be what the user answers when we ask, tell me your last name. It has logic to it. So let's see if it works. Let's run this with Shift F10. It asks me my name and the program does nothing more than that. It just waits. So I'm going to tell it again that my name is Federico. And we're going to hit enter. So it did not advance with the printout as it did before. Now he waits for me to continue giving him the information he needs to make the printout. And my last name is Garay. And now when I hit enter, it is formed. Your name is Federico Garay, in perfect English, with perfect spaces between each of the words. The end user, when he sees this sentence, cannot distinguish if it is a string or if it is composed of a concatenation. So it has worked as expected. Sometimes, and although it is not necessary, you can also enclose these inputs within brackets, just for the purposes of making it easier to read this concatenation, and visually we can understand that there are some things here that are separate from the others. So again, I thank you very much for joining me in this lecture, and Phil will now be waiting for you in the next one.
The most awaited moment of your first day of study has arrived. You are going to create your first solo program, and you are going to do it applying everything you have learned throughout this day. Imagine this situation. Your best friend has started a brewery and has everything ready. His product is fantastic. It has body, good flavor, good color, and just the right level of foam. But it lacks an identity. He can't think of a name for his beer that would give it a unique and original identity. So, you come to him and say, "Don't worry, I'm going to create a program that will ask you 2 questions and then tell you what to name your beer." It's as simple as that. I know that in the real world we wouldn't need to develop a software just to ask it 2 questions, but until we learn a bit more functionality, well, our programs are going to have to stay in the realm of simplicity. Yet, if you're just starting out, this is going to be quite a challenge. You're going to create Python code that asks your friend to answer 2 questions that require a single word each, and then displays those combined words on the screen to form a creative brand. You can use any questions you want. The idea is for the outcome to be original, creative, and even funny. And if you want to add some difficulty to your challenge, I suggest you try to have the name of the beer printed in quotation marks on the screen. Remember that there are different ways for the print function to show the quotes without interrupting the string. And it's also possible to print our text in at least 2 lines using line breaks within the code. Well, try to do it on your own, and if it gets complicated, don't worry, we will solve it together in the next lecture. Cheers and good luck. Did you make it? Did you have any complications? Did something give you more trouble than you expected? Well, if you made it, congratulations. And if not, don't worry about it. It is normal to encounter difficulties when we are left alone in front of the code.
And next, we're going to create our solution from scratch. And when I say from scratch, I mean from scratch of the file. So, let's open our column again so we can select our folder, which in this case is called Python, remember? And I've saved it on my desktop. Here, I right-click to choose a new file. And this is going to give us the opportunity to create the name of the file, which I'm going to name Brewery, because it's to create the brand of my beer. And I don't have to forget to put the .py, so the system knows it's a Python code. So we press enter. Our file is created. And here we're looking at the inside of the Python folder. This file we're seeing is already open here. So we can start writing code directly into this file. We're going to choose the column to see a little bit better. Now my way of solving this is going to be to start by expressing what it is that I want to be printed on the screen. And the prompt that gets printed on the screen is "the name of your beer is," and then the name of the beer. So let's do that. So print is the command for something to be displayed on the screen. I'm going to put it as I expect it to be displayed. So we open the quotation marks and we say, for example, "the name of your beer is," and then comes the name. But since we don't know it, we're going to put, for example, word 1 and word 2, all in a row. Now remember that we want these 2 words, the name of the beer, to appear in quotation marks. So we select it completely and put single quotation marks so that it appears just like that. Well, we already have what we need to be displayed. Now let's design the structure of how we want it to be displayed. We want to display first a complete string that says, "the name of your beer is." That leaves this space and shows this first quotation mark. And up to here we know what we have. Beyond that, no, because we don't know the words yet. So here we're going to close the string with double quotation marks. Notice now that I'm getting the following as an error. Let's leave a space to put the plus, which means concatenate with. Well, with word 1, which we don't know yet. After word 1, we're going to need a space to separate both words. So we're going to concatenate here with a space between quotes. It will be a string containing only a space. But we're going to put another plus sign to concatenate with word 2. And then we need this last single quotation mark to appear. And for that, we need to transform it into a string that's going to be concatenated. And here we can see it all very well. So we zoom in and you can see, maybe this is a little confusing, but what we have here is a double quote, a single quote, and a double quote to generate a string that contains only one single quote. So as you can see, if I get out of this form of this line, the system is understanding everything just fine, except for word 1 and word 2, which gives me an error because Python says, what is this? I don't know where to get this word 1 and word 2. If it were in quotes, Python would know that it's a string, but it's not. So where do we have this? Well, we're going to create it, and now we're going to replace these words. So we need two inputs. A first input that asks him something for the user to say a random word, which is going to be the first part of the beer brand. And then we need to ask him a question that we can answer with, for example, the name of a city. And we're going to say, what city would you like to visit? So we close the question, put a colon and leave a space. That will be the first input we need to replace word 1. For word 2, another input asking him, for example, something that he can answer with a colour. And it will be something like, what is your favourite colour? Here you can get a little bit creative, generate as many questions as you want. The answers can be funny. This is an exercise. You have to have fun. So get creative. Well, we already have the two pieces of code we need to replace these words, and we can do it. I'll select the first one, I'll cut it with Ctrl X, and then we're going to replace it here with Ctrl V. And we're going to do the same thing with the second input that's going to go here in place of word 2. And now we have the complete sentence. Another thing I'd like to do here is to add a line spacing so that the answer looks to be on many different lines. For now, we're going to run it to see what it looks like. Note that if I now want to run this with Shift F10, that will be executed. It is not a file called brewery, but this file is called first project, which is what we've been working on throughout this whole day. And probably if you're following my steps, you'll also have here first project. So we can't use this triangle to run it, nor can we use Shift F10, as you see here in the shortcut, because that would execute this other first project. So we'd want to change it to brewery, but if we open here, it's not loaded yet. There's the main and then there's the first project. The way to add brewery here for a run option would be to come to run, and instead of going, as we're always going to the first one, which is Shift F10, we're going to do this other run, which is with Alt Shift and F10. When we execute this one, it's going to give us a choice of which files that exist in this project are the ones that we want to execute. And in this case, it is brewery. That is going to be executed as soon as we select it. And in fact, here we have it. So before advancing, I want you to see that now brewery appears in this drop down and we can choose it to make the execution from now on with Shift and F10. Well, let's come to the code. And here it says, what city would you like to visit? Well, look, the truth is that I'm dying to visit Barcelona, so let's put this. And what's your favourite colour? Let's say it's purple. Now yes, it tells me that the name of my beer is Barcelona Purple. Great, I have my answer. So the next step in the challenge, to add a bit of complication, was to have this separated into two different lines. So how can we do that? On one hand, we could do it with different print lines, but if we want to do it all at once, I'm going to make use of the backslash and N, which stands for new line, as we learned throughout this day. So, after it says the name of your beer, we're going to put here, instead of a space, a backslash with an N. This tells it to jump lines. So the second line is going to say is and the full name. And we're going to make it so that after this line with the quotation mark ends, it will generate a \n, that is a new line, and it will say, I don't know, congratulations, or whatever. With this, we would already have 3 lines. So we run it. Do Shift F10, now yes, we can do it. What city would you like to visit? Well, I've changed my mind. Now I want to visit London. And it tells me that my favourite colour is, let's put yellow. It's not, but we put it for a change. And on 3 different lines we have, the name of your beer is London Yellow. Congratulations. And that's how we've done it. If you've made it before watching this lecture, congratulations. And if you've achieved it by watching this lecture, it is equally valid because it is a way to learn and see how someone else has solved it. The code may seem very simple up to this point, but when we get on our own and we are left without the instructor, we get our books burned and sometimes we need a little help. So it's perfect. You're here and I congratulate you for being here, finishing your first day. If you did it in a different way, that's valid too. And of course it is, because in programming there are many ways to achieve the same result. And then of course some may be more efficient than others, more economical than others, more elegant, but the point is at this stage of the course is that you have been able to do it. So I thank you for following me throughout the solution of this project, and I recommend that you don't miss the next lecture, which is a very special lecture. Seriously, I'll see you there.
Welcome to day 2 of your training to become an advanced Python programmer. Today is a very special day because you are going to learn many factors that, despite being basic, are fundamental for your future in this career. So don't stop giving it your best. As every day, today you are going to create a program that works by itself. And this time we are going to work with numbers. You are going to create a commission calculator. The employees of a company are going to use your program to find out how much they have earned in commissions this month. So let's be very careful about this. As I said, keep in mind that the first programs you're going to create, like today's, are not going to be super attractive or colorful or anything like that for now. They're just going to be text on the screen. To achieve today's goal, you're going to have to learn a few things first. For example, knowing the different types of data that exists in Python, doing conversions between types of data, knowing what variables are, knowing a bit more about how to format a string to be able to print it on the screen, doing mathematical operations, and also knowing how to round numbers. So prepare your coffee, your tea, your bottle of water, or whatever it is that will give you energy that you need to have your best day ever. I'll be waiting for you in the next lecture to start an unforgettable day together. Let's go. Welcome to this lecture about data types. What are they exactly? Well, when we write code, we manipulate data or information just like we did when we printed the words "Hello World" or your name, some numbers, all that information or data. The data comes in different types. The word hello is a text data type or string, and the number 150 is a numeric data type. So far, we have used the definitions print and input to manipulate only text and numbers. But text and numbers are just 2 different types of data. And those are not the only ones. And in this lecture, I want to introduce you to the most common ones. In programming, text is known as a string and is defined by the letters str. Any word, sign, space, or even number that is enclosed in quotes is a string. We also have integers. You already know them. In programming, we define integers as int. And any integer, positive or negative, that is not enclosed in quotes is an integer. The main advantage of integers is that you can do operations on them. They're numbers. But they are not the only numbers that exist, because there is another type of data known as floating or float, which are decimal numbers, also positive or negative, and you can do operations between them as well if they are not enclosed in quotes. If they are enclosed in quotes, they will no longer be floats and will become strings. The following group of data types that I am going to mention are considered as collections, because even when they are also data types themselves, they contain groups of elements inside them. The first of these collections are the lists, and its definition is LST. A list is nothing more than an ordered collection of objects. Lists are written in square brackets, and they can contain objects of all kinds. They can be many strings, integers, or floats, or even a collection of elements of different types of data. The important thing about lists is that the order of their elements is important, as each element has a numbered place, or index, from 0 upwards. In this example, the word Mars has the index number 4. The next data type, also a collection data type, are the dictionaries. This data type is defined as DICT, and its contents are written between braces. Dictionaries consist of grouped pairs of words. Each pair contains 2 elements, a key and a value. Think of the dictionaries you already know, which consist of a set of pairs that are a word and a definition. Well, here you have something similar, a key and its value. Note, however, that pairs are not ordered within the dictionaries. While each pair has its internal order, first the key and then the value, the pairs are not ordered with an index within a dictionary. I know it all seems to get complicated from here, but I promise that when you see these data types in action and see what we use them for, it will be much clearer than it is right now. What follows are tuples or tuples, however you want to pronounce it, and they are defined as tup. They are written in brackets and are very similar to lists, since they are an ordered set of elements, and their elements can be any data type. However, they have a fundamental difference. Their order is immutable. In lists, there are methods that allow you to add, delete, and even reorder elements. Tuple elements, on the other hand, are elements that have an order that can never be modified. This limitation may seem unnecessary, but as we will see later, it can be very useful in some occasions. Another common data type, also a collection, are the sets. They are defined as set and are written between braces. A set is nothing more than an ordered set of unique elements. Lists, dictionaries, and tuples can have repeated elements, and that is what differentiates sets. In this case, each of its elements is unique and unrepeatable. And finally, we are going to mention another data type, and this one is not a collection but a simple data type called Booleans, or bools, which are very simple logical values. A Boolean is data that can only have 2 values, true or false. This type of data is very useful, especially when we need our code to make decisions. In those cases, we are going to use Booleans to know if a condition is fulfilled, true, or it is not fulfilled, false. To achieve today's goal and create the code for our program, we will continue working with text and numbers, or strings and integers, and we will add decimal numbers, or floats. We're going to know them in more depth, and we are also going to do some interesting things like conversions between types of data. For example, transforming a string into an integer and vice versa, or an integer into a float. In the near future of this course, you will need to start working with the other data types I just mentioned. But these lectures are fundamental, so pay close attention, do all the practices, and above all, have a lot of fun. Welcome to a lecture on variables, one of the most important concepts in programming in general. And to explain what a variable is, I want you to think of a box, a simple box. This box is a space that allows us to put things inside. Now let's name this box. For example, my favorite book. Now this box exists for me to store in it the book I liked the most. So I do it, and now my box has content. It has a value. But let's imagine I read another book the next month, and I like this new book so much it becomes my new favorite book. So I replace the content of my box with the new book. Basically, my box is a variable. It is a space that I have created to store something, and that something can change. It can vary. That is why it is called a variable. In programming, a variable is a memory space to which you give a name, and it is reserved so that you can store it in any content or value that you want. You can even leave it empty if you want, and it's still a variable. Let's dive deeper into variables right now in PyCharm.
Thanks, Phil. But before we start writing our day 2 code, let's get a little bit of order in these folders. Because up to now, we've just been mindlessly adding files inside this root folder Python. But I'd like to be able to save this in folders so we can organize it and have everything easier to find, because at some point we're going to have hundreds of files. So we right click. In Python, we create a new directory, and this creates a folder that we're going to give a name. It can be day 1. And there we'll put inside everything we learnt yesterday. Then I select the 4 files that were created yesterday, and we put them in day 1. It's going to ask us to refactor because we have to relocate those files to their new path. So we refactor. Everything is now saved in day 1, and we can see it like this. So we're now going to create a new directory that this time is going to be called day 2. And day 2 is going to contain for now only a new file to which we're going to name as variables. And remember to make it .py so it understands the Python code. So we close these other files from yesterday. We can also close our column here, and now we can only see day 2. Well, we said that we're going to learn variables, and that variables are boxes that contain a value, and that value can be changed. So let's create our first box, which is going to be called name. We declare it this way directly with the word that we want to use as title for that variable, and that we're going to assign a content to it. This is to say that it's going to be equal to something. This time I'm going to give it a name, for example John. John is the content of the variable called name. So if I want to print, for example, the variable name, I should print on the screen not the word name, which is not a string, it doesn't have quotes, but the content of the variable. And let's execute it. Let's come here to execute. Oh, well, we still have the brewery here, so we'll need to find our new file. We're going to do that through run. Run again, and we choose variables this time. Okay, it's run, and now it shows us John instead of name. It shows us the content of that variable, which is John. While we're at it, let's adjust the console so that it doesn't show down here. This isn't comfortable for me. So let's click on this icon here to choose Move To, the upper right corner, and now we can see our console next to our code. It looks much more comfortable to me. Alright, as we said, variables are just variables because they vary, so we can assign another value to the variable called name. For that, I simply declare it again, and I say that its new content is Laura, another different name. What do you think will happen if I now print name again? Notice that it is the same command I gave before. It is not different in any way, and it is another point in the code. Take a second to imagine what is going to be printed on the console. Well, let's print it out and see what it looks like. First you see John, and then Laura. And this is because although we printed both times the same variable, at this point of the code, in line 2, the variable still had as value John, and that's why it printed the word John. We then assigned a new value to it. Then we asked it to print again, but this time it printed with its new value, which is Laura. And this is what makes variables interesting. You can make them dynamically change their content. So regarding the names we give to the variables, I named it as name. I could have named it as anything. it could be called XXX, XXX. And if I asked it to print XXX, it would work exactly the same. The important thing is that not the name of the variable, but its content, and that you then invoke it correctly. There are, however, some conventions and good practices to name your variables, and we're going to see that in the next lecture. For now, let's continue learning, and let's see what we can also assign a numeric content to variables. For example, integers. If my variable is called age, it can have a value that is, for example, 30. And if I then print age, we're going to see exactly that. We're going to see the value 30. Variables can also be added together if they are numbers. For example, let's have another variable called age2, and age2 will be equal to 15. And if I print age plus age2, we run it, and it prints the sum, which is 45. I have added two values that were assigned to two variables, and it worked exactly like a mathematical operation. So it is also interesting that you can use the input function that we have used so far to ask the user to tell us something. For example, tell me your name, which would be something that we ask the user. We're going to do it inside the input function. We can ask them to tell us his name, but what if this time, instead of printing it directly, we assign this user input to a variable called name. Name, it says here, is the same as whatever is entered when we ask, tell me your name. So now I can print a concatenation that says your name is, then a space, then I concatenate, and set the variable name. So let's see what happens when we run this. It asks me to tell it my name. My name is Federico. Your name is Federico. I already knew that, but it's nice that I was able to do it this way, by storing my value inside a variable. So now I can, well, I don't even need to print this. We're going to delete the print box, we run it, it's going to ask me for the name, I say Federico, and you can then come up with the other code and never print the user input or use it for any other purposes. But the good thing is that now you can store this information in a variable and manipulate it later as you wish. You can also concatenate variables. If your variable has a string value, for example, it will say hello. We leave a space and the other one will be called name2, and it will have the content Python. Well, let's now create a variable called phrase. That will be equal to the concatenated content of name1 plus name2. And if I print now directly phrase, what I'm going to get on the screen is going to be an error. Oh yes, because the first variable was name, not name1, sorry. So now we run it again and I get hello Python, because phrase has now not only one word as content, but two variables that each has a content. Name is hello, name2 is Python, and phrase is hello Python. And if we do it with numbers, we can also add them together. Let's suppose that the first variable is going to be called age, and it is going to have the value of 30. The second one is going to be called age2, and it is going to have the value of 50. And phrase, well, let's leave phrase as the name, will contain age plus age2, and we print phrase. What we will have on the screen, it will be 80, the sum. Now what this variable did was to contain a sum composed by two variables. It worked exactly the same. So this is enough to begin to see the use of variables. We will expand on this much more throughout the course. So thank you again for joining us in this lecture, and see you in the next one.
In the previous lecture, we learned how to use variables, and we saw that we can name our variables whatever we want. So if I created a variable in which I'm going to store the name of my dog, it can be called dog, or my dog, or even the letter D. It will work just the same as long as when I need to invoke it, I write it exactly the same as when I declared it. But even though you can write your variable names however you want, here are some rules to follow. The most important one is to make your code easy to read, like text. If your variable is called dog or dog name, you are making it clear what it contains. And if I read this sentence in your code, I will understand its logical meaning as easily as when I read a sentence in plain English. If in order to type less, you put something very simple like D in your variable, or something very fancy like my dog has a name and this is it, your code will work fine because the machine will read it without problems. However, if a person has to read it, they will have to make a bigger effort to understand the logic of your code. So this is not a good practice. As a programmer, you will be working in a team regularly, or you even may have to read your code again in a month or a year. And when you read variable names like D or my dog has a name and this is it, you will regret not giving more descriptive or simpler to read names. Another rule is that your variable names must consist of a single unit of text. This means that you cannot use two or more words separated by spaces. So if you want your variable to be called student's name, you can use underscores to replace the spaces. In other languages, it is customary to remove spaces and capitalize the first letter of subsequent words, but not in Python. Lowercase and underscores have to be used. You can also use numbers in your variable names, but not at the beginning. Variables must always start with a letter, and you can put numbers at the end, as we saw in the example in the previous lecture. If you put them at the beginning, the compiler will return an error message. Another rule, and this one is mandatory, is that your variable names cannot contain any of these symbols. So if you want to put an insult, you'd better think of something else. Finally, you can't name your variables using special keywords like input, print, and many others that we will learn later. These are words reserved by Python to structure how the code works. If you were to call your variable print, it would generate confusion in the code because Python would not be able to distinguish whether print is a command to display on the screen or a variable that you have created. In short, think of these restrictions not as limits to your creativity, but as good practices that will help you design a readable, easy to understand, and pleasant to read code. Thanks for being here, and I look forward to seeing you in the next lecture. In Python, there are numerous data types for numeric values, but during the basic training, we are going to concentrate on the two most important ones, which, as we have already seen, are integers and floats. The difference between them is that floats include decimal values. So if I needed to handle values like ages, numbers of people, or number of days, or positions in a list, I would use integers. If my values are going to be, for example, temperatures, prices, weights, measures, I'm going to need values that support decimal places. Hence, they would be floats. Let's go to PyCharm to see how the numbers behave in code.
And so here we are in PyCharm, where I created a new file called integers_float.py. And you can do the same. I did it inside the day2 folder, and we're going to close the column to start demonstrating some of the work here. So first we're going to create a new variable that I'm going to call my_number. And my number, I'm going to declare it to have a value of 1 initially. And as you can see, it supports it perfectly. As we've done with the strings, we can store integers in the variables. And if I now want to print my number, notice this help window that PyCharm gives us when you start to write the name of a variable or a function. Some options will pop up. Since I just created my number, it is already in the options list. It has a V symbol that means variable. Pressing the Tab key or the Enter key adds it automatically without having to type it all the time. So taking advantage of that really speeds it up. And let's run this code. We're going to run and choose our new window. And here it says 1, because I asked it to print the variable my number, whose value is 1. So far so easy. And now I'm going to show you something additional. There is a function called type that lets you know what type of data we are talking about when we refer to a particular data or variable. In this case, the variable my number. So if I want to print this, so we're going to insert all this in brackets, and we're going to print it so that it shows us not only the variable my number, but also the type of data that my number is. It tells us that 1, it is an int. Perfect. This is information that is going to be very important for what follows. So let's move on. I want to show you that also my number can be composed not only by a number, but by an operation. For example, 1 plus 3. If I run this now, it will tell me that my number is equal to 4, and it is still an integer because 4 is an integer. I can also print operations done with variables. For example, print my number plus my number. This is what I'm going to print. We execute and it prints an 8. What it did was to do an addition. Remember that we used the plus inside the print to concatenate strings, but this is not a string, neither of them. They're in integers. So what the plus does this time is add. So what was printed is an 8, and it keeps telling me that my number, don't forget, is worth 1 plus 3, is an int. And now comes the thing. I'm going to change the my number, and it's going to be equal to 5.8, a decimal number. And I'm going to print just once my number, and then I'm going to see what type this variable is. So let's go to run. 5.8 is the content of my number, and the type is a float. Automatically, when I wrote the content, when I changed the value, it also changed the type of variable that it is. It is now a float variable. So we're even going to do one more little thing here in the middle after declaring the variable. Now I'm going to say that my number, I'm going to rewrite it, it's equal to my number plus my number. If I print this, we're going to have 11.6, because what is printed out is my number, which in this instance is worth twice what my number is worth. It's been overwritten and it has this new value, which is 11.6. Let's take it a step further, and I'm sure this will interest you. What if I say that, for example, my number is equal to 5 plus 5.8? Then, let's not do this count, let's leave it at that. So let's print my number. What would you expect? That my number here is an integer or a float? It has two values in its operation. So let's see. Well, it gives us the operation 10.8, which is 5 plus 5.8. And it tells us that it's a float. Of course, because it doesn't really matter the content of these operations, but the result of the operation. Since the result is a float, it is 10.8. Then the data type of my number is a float data type. And let's take another step further to encounter a problem that will interest you. We're going to delete all this, and we're going to create a variable called age, for example, and we're going to give this variable a value through an input. We're going to ask the user to enter his age. Tell me your age. And then what we're going to do is print out a sentence that says your age is. We leave the space and concatenate with age. This should work. In fact, the compiler doesn't flag any errors. If we run it, tell me your age, 30 for example, and it returns, your age is 30. It worked perfectly. Then I could deduce here that I can make operations with the variable age because it has a value of 30, a number. So now I can say, for example, that new age, another variable that I'm going to create, is going to be equal to 1 plus age. This, in theory, would have been given 31, in the case of this example. And then I'm going to print. Well, if you're going to be 1 year older next year, the sentence is going to be, you're going to be, we close the quotes and then add new age, which is the variable containing age plus 1. So it should work, of course it should. We print it out. We put in that you're 30. It tells me your age is 30, but then it throws me an error when it comes the time to print what you're going to turn. It tells me that there's some kind of operator here that plus cannot support, because plus either does concatenations with strings or sums with integers. But if you have integer and string in the same operation, it can't operate. But you may be saying, I have no strings here. I only have two integers, 1 and 30, because age is loaded with a number value. Well, even if it has a value of 30, everything that the user enters through an input is going to be taken by the system as a string. So this is a string that has the characters 3 and 0. It's not a number that we can do operations with, and I'm going to show you that. By removing this bottom part and simply printing the type of age, we run it. I give an age of 30 again. Your age is 30, and it tells me that the variable age has a value that belongs to the class string. So the data type is not an integer. This means that I cannot do operations with this number. That if I want to, for example, to add age twice, look what we're going to do here. We're going to print age plus age. We're going to eliminate the type here, and it is no longer necessary. We're going to run it. We're going to write 30 again, and it tells me 30, 30, or 3030. It didn't do a sum. It didn't give me an error either. What it did is a string concatenation, and then I have a new string that says 3030, because I put age twice. So if I want to receive user input that is treated as numbers, I will have to do some operations that are called conversions between types. And we will learn about that in the next lecture.
One of the advantages of Python about variables is that you can store any kind of data in them. For example, the variable myData can contain an integer, then replace it with a float, then change it to a string, and it would always be able to store whatever you put inside. In most other programming languages, when you declare a variable, you have to give it a name and assign it a specific data type, for example, integer. From then on, that variable will only hold integers. So that's what's great about variables in Python. They only get a name, and you can store any kind of data type inside them. On the other hand, there may be situations where you need to convert the contents of a variable to a different data type, as we saw in the previous lecture, when we wanted to take a user input, which is a string data type by default, and treat it as an integer in order to perform a mathematical operation on it. The process of converting a specific data type into another is called casting. And there are two types of conversions, implicit and explicit. Implicit conversion is done automatically by Python. It happens when we perform certain operations with two different types. And Python solves it by transforming the data type without us noticing. In contrast, explicit conversion is when we expressly ask through the code for a data type to be converted to another data type. And how do we do it? By expressing that we want to put a certain type of data into another. For example, if I have a variable called myValue that contains an integer, let's say the number 1, I can reassign it to another variable with a different data type. For example, a string. Now if I print this variable, I will see the same value, 1. But this time it is no longer an integer, it is a string. So now I can do other things like concatenate it with other strings. Let's go over to PyCharm, and Federico's going to show all of this in action.
Thank you, Phil. And let's see how these conversions behave within this file that I just created called conversions within the day 2. You can do the same, and let's start learning how to make implicit conversions, which are those that Python does automatically when it's possible, without us having to express, I want to make a conversion. Let's see it with an example. We're going to create a variable that is going to be called num1, and I'm going to give it a value of 20 initially. That is to say that it is an integer. I'm also going to create another variable called num2, and it will have a value of 30.5. So num2 is a float. And in fact, if I print the type of num1 and then print the type of num2, and now I run this, run again, and we go to conversions, and there it is. It tells me that the first variable is an integer and that the second variable is a float. That's perfect. So far, no surprises. What I'm going to do now is here in the middle, before the data type is printed, I will do a rewrite of num1. I'm going to ask that now num1 is equal to the value of num1, i.e. 20, plus the value of num2, i.e. 30.5. So now num1 is going to be 50.5. So let's run this. And now the funny thing is that the result of printing the two types of num1 and num2 is now a float for each one. Because in num1, when you did an addition that would now give you a value of 50.8, it had to automatically transform or convert to a float. Num1 stopped being an integer, it became a float. And at the moment of printing the data types, we already had two floats. This is an implicit conversion because we didn't ask Python, please convert number1 to a variable that we can support float. No, Python automatically did it for us and saved some work for us. There are situations where we have to explicitly ask for it. Those are the explicit conversions, and that's what we're going to look at next. Let's declare a variable a type of float. For example, let's name it num1, and this variable is going to have a value of 5.8. We're going to print num1, and we're going also to print the type of data that corresponds to num1. It's going to tell us that 5.8 is num1, and that is a type of float. Perfect, we already knew that. But if I now want to transform this 5.8 value into an integer value, the way I have to do it is this. Well, we're going to lodge it in a variable, named for example num2. And we're going to say that num2, it is equal to an integer of num1. So we want it to be transformed into an integer, and in brackets, of num1. The reading of this would basically be, I want num2 to be equal to an integer conformed by the num1 value. If I want to print this, let me copy this first and paste it here, but I change it to num2, and we execute it. It tells us first 5.8 float. It is what corresponds to the lines 2 and 3 of the code. Then we have created the num2 and we have made the conversion. We see that the printing of num2 is a 5. What it did was necessarily to eliminate the decimals because num2 only admits integers. And note that what it did was not round it, because if it had rounded it, it would have taken it to 6, since 5.8 is close to 6. What it did was eliminating all the decimal points, and it left nothing but the integer. Here we can see that the data type of num2 is integer. So here I've done a conversion. I've transformed the value 5.8, which was lodged in num1, into an integer using this approach, which is the first data type that you want to have, and then in brackets the value that you're going to transform into the data type. So now let's try to do what we wanted to do before with the variable age. Let's create that variable. We're going to say that it is going to be equal to an input with the prompt, tell me your age. We're going to do it in the same way as before. But this time, to be possible to succeed, we're going to say that the value of age, which comes in a string, because that's the value the user enters, we're going to convert it as an integer of age. So now age is an integer, and I can make operations with that. Then I want this variable new age, the one that I used before to try to do a sum unsuccessfulully in the previous lecture. I want this to be equal to 1 plus age. And now you can see that I'm not getting any errors in the code. It is allowing me to do it. And now if I print new age and run the code, it says tell me your age. 30. And 31 is the result of adding a value to age, because age is now an integer thanks to this conversion we've done up here. And actually, to make this more interesting, we're going to put here, after the user has given his answer, we're going to print the age type, and we're going to copy this line and we're going to print it again after we've done the conversion. Notice how the program behaves now. Age 30. It tells me it's a string, and it converted it into an integer. And here we have our 31, yes? The problem that we would have here is if what I want to do is to create a string in this, because it tells me the new age is a sentence. Because if I try to do it, if I want to include in a sentence that says something like your new age is going to be, here we're going to leave the space, and I want to concatenate it with new age, which is the value that I already have. Will this work? Will it not work? Let's see. Let's execute it. My age is 30. It says string. It says integer. And then it tells me that there is an error here. What kind of error? It says that I can only concatenate strings, but not an integer with a string. Of course, now that I transformed age into an integer, new age is also an integer. And as you know already, I can't concatenate a string with an integer because this plus doesn't know whether to concatenate or add. And it can't really do either because it has two different data types. What would we have to do? Do we have to transform new age into a string now? Well, we could, but it's not the most practical thing to go back and forth with data types doing transformations all the time. So in the next lecture, we're going to learn something that is going to help us solve this, which is to print strings with values of any type by formatting the strings. So let's go to the next lecture.
We often need to write a string that also contains other variables. For example, if I have the information about the color of a car and its license plate number, and I want to print a sentence containing both values, as far as we know now, I would have to resort to casting to transform some of those values. And I would also have to do a lot of concatenations that may become too long, impractical, or difficult to read. That's why we're going to learn how to format strings in this lecture, so that we can solve this in a more practical way. In Python, there are two ways to do it. The first one is using the format function. Its syntax is very simple. You write the phrase in a single string without concatenations or anything, but you replace the values that are contained in variables with two empty braces. After the closing quotes, you add .format, and then in brackets and ordered, the variables containing the values to be replaced, separated by commas. Here it doesn't matter if the content of those variables is string, integer, float, or whatever. Format will display them as strings without the need to cast and change the data type of your variables. This solved a lot of problems when it was incorporated into Python because it's very handy, although it has a big disadvantage. It's not very readable. To understand this sentence, the human eye has to go back and forth to make sense of it. That's why version 3.6 of Python incorporated the so-called literal strings, which gives a twist to this format, doing it in this way. When constructing your string, you add the letter F before the first quotation mark. This tells Python that this is going to be a literal string. And then you put the braces to replace the variable values. Only this time you put the variable name inside the braces. Isn't it cool? Issue solved. Now formatting strings is practical and readable at the same time. You might say, okay Phil, but if the second approach is so great, why don't we just learn that one and that's it? Well, because there are many people who use both ways, and in your career as a programmer, you're going to find a lot of codes written like this, and it's important that you know how to interpret it. Now let's go to PyCharm and put this into practice.
So let's put into practice these two types of formatting strings. We're going to do it in this new file that I've created called formatting strings. Let's start by creating two variables that we want to be incorporated into our string. These two variables will be x equals 10 and y equals 5. I've already have two variables with two values, two integers, and I want to create a statement that says my numbers are this one and that one. So what I do in the traditional way would be to say print my numbers are, and with the old way I would have to leave a space here. Concatenate, then I would have to put the value of x, but I could not do it because x is an integer and I want to transform it into a string. So I would have to say str to convert it as we have just learned, and then a space. Concatenate this with a string created with the value of y, and I believe that here we would already have it. In fact, let's see if we run it. Run, run formatting strings, and we did it. It says my numbers are 10 and 5. I have achieved it. But as you may have noticed, using a lot of conversions and concatenations, and this is not practical at all. So let's delete all of this. And if I want to do it with the format function, we directly say my numbers are. And here we write some braces to occupy the value of the first number, and other more braces to occupy the value of the second number. We close the quotation marks and then we write format, so that this method is applied, which is going to ask me to enter inside the brackets of values that are going to occupy these braces in the correct order. So we're going to put x, comma, y, separated by commas. And you can continue adding values if you have more keys. And now if I run this, it says my numbers are 10 and 5, but it's created in a much more practical way. I didn't have to do any concatenation nor transformation. Notice that if I change the order of the numbers here and put the y first and the x after, when I print it out again, it will tell me that my numbers are 5 and 10. It has flipped them round, and I didn't have to do that much. I could actually do operations as well. Look, we're going to change this whole sentence, and we're going to put it that what it says here is the sum of. And we're going to put the first number, and we'll put the second number, is equal to. And here we put one more set of braces. And what we're going to do is put in format. First y, then x. And we're still missing one more value for the third set of braces, which is going to be the sum of y plus x. So I do the operation here in this third space that I've reserved inside of format to occupy this key. So we're going to run it, and it tells me that the sum of 5 and 10 equals 15. We are able to solve the operation even without the need to create a variable here that we would have called z, and that it would be equal to x plus y, which would have worked in the same way. I would have replaced this operation here with z and printed it out, and it would have given me exactly the same thing. I just solved it in a different way. So this is one more way to format your strings. It's efficient, it's practical because you don't have to do concatenations, and it was solved in a very easy way. But it's not quite readable, we could say. So let's try also the second way to do it. Let's start from scratch now to be able to work with strings and with integers. So we're going to delete all of this. And we're going to create first a variable called color. And its content is going to be red. And we're going to create one more variable that's called license plate. We're referring to a car, obviously. And the license plate is going to be a number. Let's say 541926. Well, what are we going to print here? We're going to say print, we open the brackets, and we're going to use the other way of doing it, which is with something called literal strings. And as Phil told you, the first thing you have to do is put the F before the quotes. This tells Python, hey Python, pay attention. This is going to be a literal string. And we're going to compose it like this. The car is. We write the braces here, and inside the braces we put the content, which is in this case the variable color. And its license plate is. And we open keys. And here we put license plate, which is the next value. Then the key is closed. We don't need to put format or anything because the values are already in here. If we run it, we get the car is red and its license plate is 541926. That is to say that it worked perfectly. And this way I believe that it is a superior approach because it is not only practical as the format function, but it is also readable. The car is color and the license plate is license plate. It doesn't get any easier than that. So this is the best way, I think, but you have to learn all of them and use them one that you're most comfortable with. None of them is wrong, they're all valid. So now you know how to do it. So I invite you to the next lecture where we have something amazing to teach you.
Mathematics, everyone's favorite subject at school. In programming, numerical operations are very important, and that's why you're going to learn how to do some basic and not so basic operations in Python in this lecture. As you can imagine, in order to add, subtract, multiply, and divide, we use our old and familiar basic operation signs. But there's much more than that, and you're going to learn it right now in PyCharm.
Okay, let's put these operations into practice inside this operators file that I've just created. You can do the same, and let's start with basic operations like addition, subtraction, division, and multiplication. We're going to create some very simple variables. X will have the value 6, and Y with a 2. We will do some operations with them. And since we learned how to make literal strings, we're going to do that in that way. We are going to print it. Remember to use the F to warn Python that it is a literal string, and that I want to enunciate an operation with its result. For example, X plus Y is equal to whatever. So I open the braces to put inside X. That is to say that the value of X is going to be printed, which is this case 6, plus I open the keys to write Y, that we know values 2, equals, and here I open the keys and put the operation that would be X plus Y. And now if I run this, I'm going to go to run, and run again, and we pick operators. We get 6 plus 2 equals 8, that's right. Now we're going to copy this line, and we're going to paste it 3 times to do the subtraction, here as well. We're going to say that X minus Y equals X minus Y. We use the minus symbol to do subtraction. Down here we say X times Y equals X times Y, using the asterisk. And down here in the last line, let's say X divided by Y equals X slash Y. The slash is the division symbol. If we run this, we have 4 lines saying 6 plus 2 equals 8. 6 minus 2 equals 4, and 6 times 2 equals 12, and 6 divided by 2 equals 3.0. Notice that the division returns a float value. Well, let's move on to something a little more complex. Let's add one more variable called z. We're going to feed a 7 into this one, and the first thing I'm going to do is show you what's called a floor division. And what is a floor division? Floor division is an operation that divides 2 numbers and rounds the result down to the nearest integer. So it'd be the same than doing a regular division, but if the result is a floating number, it deletes any decimal number and leaves only the integer. For example, 7 divided by 2 should be 3.5. But if we do a floor division, we get 3, because the 0.5 will be eliminated. So let's try it. We're going to do a print statement. Let's make it a literal string, and we're going to say z, divided to the floor of y equals, and how we write a floor division, z slash slash y. This is different than a regular division. Here we would use only 1 slash, and when we run it, we get 7 divided to the floor of 2 equal 3, not 3.5, which would be the exact outcome of 7 divided by 2, which is the division to the floor. Now let's learn the modulo or mod operator. The modulo returns back to the remainder of a division. In other words, if you do a division and after you get the result here, there is a remainder. That is the modulo. For example, 6 divided by 3 equals 2, and there is nothing left over. So the modulo of 6 divided by 3 is 0. But if we do 7 divided by 2, how many times does the 2 fit completely inside 7? It fits 3 times. And even when we have a remainder, we cannot include 2 for a 4th time, right? So that remainder is the modulo. Then in this case, we can say that 1 is the modulo of 7 divided by 2. So let's see it in execution. We're going to print it also with a literal string. We're going to open the quotation marks and we're going to say that z modulo of y, which is 2 in this case, is equal to, and how do we write it? Well, we use the percentage symbol. So in this case, it would be z percentage y. That's z mod y. Let's run it to check that 7 modulo of 2 is equal to 1 as we calculated. This type of division is also never done in real life, but we use it a lot in programming to detect when a number is even, because if we try any number, mod 2, and its result is 0, it means that there is nothing left over. That is to say, it is even. So it's a clever way to discover odd numbers. So let's look at the powers now. Let's copy this up here and let's drop x to the power of y is equal to x. And we put twice the asterisk symbol and then y. These two asterisks is what tells Python that we are going to power a number to another factor, which can be 2, 3, 4, 10, or whatever you want. So if we run this, we get 6 to the power of 2 is equal to 36. Because, of course, 6 times 6 is 36. And let's check this another way. Let's copy it and let's power something, but this time to the power of 3. We're going to say that x to the power of 3, I don't have a variable for 3, so let's just write 3 in here, is equal to x 3. And we run that and it's going to tell us that 6 to the power of 3 is equal to 216. Great. And finally, let's learn the square root. We're going to print one more line here and we're going to say that the square root of, we're going to delete everything that follows. We open up a set of keys and let's say I want to know the square root of 6, for example. So I put the x, the word is, and then I should write the operation for the square root, which is first the value you want to take its root, 0.5. The result of an operation where you have some value, 2 asterisks and 0.5, is going to give you the square root. And if we run this, here we have that the square root of 6 is 2.449, and so on. And in fact, this result gives us the basis for what we're going to learn in the next lecture, which is how to round numbers. So, don't miss it. Phil and I are waiting for you in the next lecture.
As you know, floats can have a lot of digits after the dot, and that's very useful when you need to be very precise, but it's a bit much when you want to be clear. For example, if 6 friends and I spent $90 on a meal, and they asked me to calculate how much each one of us should pay, it would not be very practical for me to ask them for $12 and 8,572,571,429 of a cent. They are never going to invite me again. That's why we use rounding. And Python has a method called round, which allows me to remove as many decimal places as I want, so I can visualize and communicate my numbers much better. The rounding syntax is as simple as telling Python, please round this number, or round, and then in brackets 2 parameters. First, the number we want to round. Here we can put a number, an operation, or even a variable, and as we will see later, also a function. That is the first parameter, the number that we want to round. The second parameter, which goes after the comma, is the number of decimal digits we want our result to have. If you don't put anything here, Python will consider that you don't want any decimal numbers after the point by default. Please note that round can round up or round down depending on which number is the closest. So 5.3 will be rounded down because 5.3 is closer to 5 than 6. 5.8 will be rounded up because it's closer to 6. 5.5 is also going to round up. That's the tipping point. Let's take a look at this in practice in PyCharm so we can really fully understand it and put it into practice.
Let's see how this rounding thing behaves in PyCharm. Let's start by trying to print this operation that we just talked about in the example, dividing 90 books by 7 people. And if I run this, choosing the round module, we will get 12.8571, etc. This is not really a number that we can socialize among our friends. So let's try to write our value inside the round function. So we open the brackets, close it at the end of the value and run it. And now we're going to get 13 because 12.8 is rounded up because it's closer to 13 than 12. And the approach here was to apply the rounding function inside the print statement. But what if we do it differently? We also can. We can store this value in a variable, for example result, and let's say its value it's around 90 divided by 7. And inside the print statement we only set result, and what we are going to get is exactly the same. Then we can do the rounding inside the variable, or at the printing time as we just saw. Or we can also generate another new variable that's called rounding, and it's equal to round, result. Well, there are a lot of ways to do it. As long as somewhere in your round operation it's getting the value that it has to round, it's going to work and it's going to be valid. And now let's look at a different example. We're going to eliminate all of this and we're going to write a new decimal number. We're going to put it inside a variable called value, and we're going to give it a content of 95.66666, etc. A huge amount of sixes. And now I want to round this value, but not to the point of losing all my decimal values. Let's say I want to see only 2 decimals. Well, for that the round function allows us to pass an argument to ask for that. Let's type round. Let's open and close the brackets, and as Phil was telling you in the introduction of this lecture, round accepts 2 parameters. The first one is mandatory, is the value we want to round, and the second one is optional. We can add after the comma the number of decimal places that we want to get in our result. If I say 2 and now I print it, we run it and it tells me 95.67. It rounded up this second 6. If I had put in here that I wanted 3 decimal places, it would show me 3, and so on. That is, round always allows us not only to remove the decimals but also to choose how many you want it to show. Let's see something more. Let's remove the number of decimals. We're going to print again so that we can see only 96 is shown. And now I'm going to print not only the value but also the type of data that belongs to the value. So what do you think? I'm printing it without any decimals, so it's going to show me something that looks as an integer. It will show 96. Do you think that 96 is an integer or a float? Let's see. Let's run it. And to your surprise, it's an integer. If we do it the way we did it, notice I've created a variable that the content of the variable is the rounded number. This makes it therefore an integer because it doesn't have any decimal places in it. But now I'm going to do it differently. Now I'm going to remove the round from the value variable. Now the value of the value variable is in its number, and I'm going to round it inside print. So here I write round. We're going to open the brackets and we're going to do it here. So let's run this. And now notice the result is the same as before, 96, because we've rounded it in the print. This time it also looks as an integer. But data type is no longer an integer, it's a float. Why is that? Because when we do the rounding inside the variable, we are modifying the value itself. We're transforming it into an integer inside the variable. But when we do it outside the variable, like here, where we are doing it at the same time of printing, we're not modifying the value itself, we are just modifying the way it looks. But we haven't changed the data type, which is still going to be a float, because we've rounded it only in the print instance. How do you figure this out? Because if I print it here again, we're going to print back the value, but this time without rounding it. It still appears to me as a number of type float. That if I ask again to give me the type of value, notice it is still a float, it never became an integer. It would only be an integer if I round it inside the declaration of the variable. I hope this helps you understand the dynamics in programming. Thank you very much for joining us, and we look forward to the next lecture.
Congratulations, you've finished learning all the content of day 2, and now you're able to create a slightly more complex program. You already know how to do things like mathematical operations, data type conversions, string formatting, and rounding. So let's celebrate with a new challenge. The situation is this. You work in a company where salespeople receive 13% commissions on their total sales, and your boss wants you to help the salespeople calculate their commissions by creating a program that asks them their name and how much they've sold this month. Your program will answer them with a sentence that includes their name and the amount of commissions they are entitled to. Now, this is not a complex program, but that's okay, you're still learning. Even though what you have learned so far is very simple, putting it all together in one program can make your new skills get a little bit messy. A couple guidelines. This program should start by asking the user for things. So you're going to need to use input to receive user input. And you should use variables to store that input. Remember that user inputs are stored as strings, so you should convert one of those inputs to float to be able to do operations on it. And what operation do you need to do? Well, calculate 13% of the number that the user has entered. That is, multiply the number by 13, then divide by 100. It would be good to print the result on the screen, so make sure this information has no more than 2 decimals so it is going to be easy to read. And then organize all that in a string that you would format. Remember, we learned 2 ways to do it, and any of them is valid. Alright, go on, try to solve it, and if it gets complicated, Federico will do it with you in the next lesson. Go ahead and good luck. Was this easier or harder than you expected? If you managed to do it and it works, congratulations from the bottom of my heart. When you see our solution, it might be a little bit different than yours, but hopefully your solution works, so congrats. If you have not been able to solve it and you felt a little overwhelmed, don't worry about it, it's normal. The important thing is that you tried, that you identified which aspects caused your problem, so now we can work on it together and get it working. There's nothing better to learn Python deeply than encountering and fixing our problems. All right, I'm gonna pass it over to Federico to solve your commission problem over in PyCharm.
And now we're in PyCharm, ready to start solving our challenge. For that, we're going to start from scratch by creating the file. But this time, we're not going through project here. I'm going to right-click directly up here where I have my folder path. We're going to choose day 2 to right-click. We choose new file and it's the same thing. This one will be named commissions.py. Never forget the py extension, and we already have our blank sheet to start programming. And what are we going to program? Let's start by creating 2 questions. We want the user to give us his name and how many sales he's had this month. So we're going to store the name in a variable called name. And that variable is going to store the input of the user when we ask him, please tell me your name, :space. And the second variable is going to be the sales. And this is also going to come from an input. It is going to be what the user enters when we ask him, please input your total month sales, :space, and we already have the 2 questions and the 2 answers stored in variables. But here we need to do something. One of these variables, sales, we need to transform its data into an integer. Because as you should remember, users' inputs always come as strings. So let's overwrite sales by making it equal to an integer, which is generated from the sales value. Remember that this is how we do casting. We say what type of data we want to get, and then in brackets the original data that we want to transform. If in this case the user would enter a text, for example hello, when we're asking for their sales, which will be a number, then the conversion would give back an error because we cannot transform a text like hello in a number. So that would give an error. Later on, we're going to see how to handle the errors and also how to make it so the user can only enter numbers if that's what we want. But we're going to see that later on in the course. In the meantime, we're going to have to deal with trusting that the user is going to enter the text exactly in the way we ask for. Well, we already have our sales value transformed into an integer, and now we can do operations with it. Then we can calculate our commission, which we're going to store in a new variable with that name, and we're going to make commission equal to sales, whatever the user entered, times 13, which is the percentage we want, and divided by 100. And there we have the percentage. Remember that if I had not made this conversion here, I could not in any way make calculations based on the sales content, because the system would give me an error. It would not allow me to move forward, but here I was able to because of the conversion. And now that I've done that, I need to make sure the user gets a rounded number with 2 decimal places. So we're going to overwrite the variable commission, and this time we're going to make it equal to the round of commission. And then what we have here is the result of this operation, but rounded. Now we are able to print on the screen a sentence that we're going to create using a literal string. So we'll put the F to be able to compose it easily. And as we said, the first thing we have to do is greet the user, using their name somewhere in the sentence. So I'm going to write hello, and between the brackets, name, which is the variable that contains the name, comma, and then I'm going to say your commissions this month are. Then I put the $sign, I open another bracket, and there I can now put commission, which is the calculated value of their commissions. Will my program run fine? Let's see. Let's go to run, and we choose commissions, and it says, please tell me your name. Well, my name is Federico. Please input your total month sales. Let's say 5,000, and it says, hello Federico, your commissions this month are $650. I notice now that here I have made a rounding where I didn't ask for any amount of decimals. So by default, Python rounded it to a whole number. But if I say here that I want 2 decimals, I can run it again, and we say Federico again, we say 5,000 again, and now it tells me 650.0. Well, this code works, and it's effective, but it's not quite efficient because it could be better. In fact, I could, for example, abbreviate here a line. Instead of doing the conversion after the input, I can eliminate this and ask directly that when the sales variable is generated, it is not only the user's input, but also the conversion is made here. That is in an integer generated by the user's input. So now I've saved a line by making it all on the same line. I could also save something else. If I have a line here that calculates the commission and then another one that rounds to it, how about if I eliminate this one that rounds? And I do the rounding right here. I want commission to be equal to the rounding of sales by 13 divided by 100. Let's set it to 2 decimal places here, and we close the brackets. So I have a rounding in the same act that I do the calculation, and this has also saved me another line. If I run this, it will work exactly the same. Fede, 5,000, and it tells me, hello Fede, your commission for this month is etc. So it's the same. You could have done it one way or the other. The advantage of this way is doing it is the code is more efficient because it takes up less space. The disadvantage is that it's less readable. It's a little bit less readable than the previous one because there are steps grouped in a few lines, but they're all good code. So whichever one you did and it worked, it's valid. Congratulations. So don't miss the next lecture, which is one of those special lectures I love to have. So I'll expect you there.
Welcome. We are about to start our 3rd day of learning, and I propose that you do it with joy and a cup of coffee, or whatever makes you feel ready, because at the end of today's lectures, you are going to be closer to being a Python programmer. In fact, today, like every day, you will learn many new tools, which will allow you to create a new program by the end of the day. Today, you are going to develop a text parser. What is that? A program in which the user will enter any kind of text, and the code will give him all kinds of information about that text, such as the number of words and the times a letter is repeated. If a certain word exists or not in the text, and much more. And although it may seem impossible now, in a few minutes, you will be able to program all of this on your own. Of course, you will have to learn some new things, like applying the index method to search for elements inside strings and other data structures, extracting text fragments, discovering the main methods and properties that strings have to manipulate and analyze their information, And finally, knowing all the data types that we still need to know, such as lists, dictionaries, tuples, sets, and Booleans. Yes, all that in just one day. So let's not waste any more time and let's go straight to the first practical lecture of the day. Python strings have more than 30 built-in methods that allow us to manipulate and parse them. In this section, we are going to learn about some of the most important ones, and we will start this lecture by learning about the index method. As you know, a string is a sequence of characters, and each character has an ordered position within that sequence. If we take the example hello, the letter H occupies index 0. Python always starts an index at position 0. So always pay attention to this when counting. E occupies index 1, L occupies index 2, the second L occupies index 3, and O occupies index 4. Empty spaces and punctuation marks also occupy a place in the sequence. So if we had a string, say, hello world, it would look like this. And there is more. In Python, we can also identify the position of a character using the reverse index, which also starts at 0 for the first character, but then starts from the right side with the -1 index and works its way down to meet to 0 on the left. And this is where the index method comes in. It will help us know two things. On one hand, knowing in which position a certain character is located. Let's suppose I have the variable myText, which contains the string hello, and I want to know in which position the letter E is. In this case, we tell Python that in variable myText, I want to know the index of the character E. If I write in this way, Python will tell me that the E is at index 1. On the other hand, if I want to know which character is at a certain position, this is even easier to write. Just write the variable name and between square braces the index of interest. In this case, Python will tell me the letter O is the one that resides there. There are many more details to learn about index, but let's see them in PyCharm.
Let's see how the index behaves in PyCharm. And for that, I've already created a folder here called Day 3. We're going to inaugurate this day's lectures with a file called index, which is what we're going to start working on right now, and we're going to start by creating a variable called myText. This is a variable that is going to contain the string that we're going to work with throughout this lecture. We're going to make a string that says this text is a test. And we're going to create another variable called result, in which I'm going to do my tests with the index method. We're going to make result to be equal to the variable myText, and we're going to open the square brackets to put the index 0 here. This means that I want result to store the value of what there is in the index 0 of the variable myText. Let's try to guess what we will get before executing it. Remember that we start counting from index 0, so in the string, the text is a test, the capital letter T is the one we should find in the index 0. Let's print it out so we can see it on the console. And what we're going to print here is result. Alright, let's run it. And here we have exactly the result we expected. The letter capital T. Let's keep trying different alternatives to see how this works. If I, for example, want to print whatever is in index 7, you do your math. I'm going to run it to discover that the X, this X here, is the one at index 7. Let's count together. 0, 1, 2, 3, 4, 5, 6, and 7. That's correct. Let's also try doing it with negative numbers. We said that we can put a negative number like -3, and Python will count from left to right. Remember, 0 is always going to be the first index. But then -1, -2, and -3, here it should give us the letter E. And indeed, we have the letter E with the -3. This is how you get the character that inhabits a certain index that you can decide to query. But now let's do the opposite. We're going to say what is in the character we have found, and we want to know what index it is in. For that, we're going to say that the result is equal to my text, and this time we're going to add here a method that belongs to all strings. And since my text is a variable that contains a string, it has all the string methods. I simply put a dot here and observe that PyCharm displays a whole list with all the methods that we dispose for our strings. This circle with an M means that it is a method, and here is index. This is the method we're interested in. So we're going to accept here we get this contextual window that gives us some help. That says that this method has 3 possible parameters. The first one is a substring, which would be the character or the word that we're going to look for. Then we have 2 optional parameters, which is from where and to where we want to search. But we're going to look at that later. Now let's just look at the first parameter, which is the substring. We're going to start by looking for the letter H, in quotes. We have a letter H here in this text is a test. And if we run it, it's going to tell us that it's at index number 1. And that's correct. The T is 0 and H is 1. But what happens if we look for a letter that doesn't exist in our string? Let's try it with a Q. We execute it and it throws an exception. It tells us that we have a value error. That's the type of our error, a value error. The substring was not found. Let's also search for whole words. If I search for the word text, it tells me that text does exist and that this substring starts at index 5, which is the one corresponding to the first T of text. It doesn't give us the index of each of the letters of text, but only the one where this substring starts. And of course, if we were to write it wrong, let's write tixt, it will throw the same exception as before. Also, the index is case sensitive. So if I search for H, but this time as a capital letter, which does not exist in our string, it will also give me the same error. Now let's search for a letter that is repeated several times, such as S, for example. What happens if I search for S? Well, the result will be 3. This means that it has told me where the first S was found, because it did the search from left to right, and once it found an S, it stopped there, and can no longer know if there is still other S's ahead. This is a feature of index that only searches from left to right, and stops when it finds the first result. But we also have, as I showed you before, other parameters for index that can help us a little with this. If I put a comma after the substring parameter, I can add an index from where it is going to start searching. So let's say I search from index 5 and execute. Now it tells me that S is at index 11. And why is that? Because it didn't include the first one, which is at the index 3. It skipped it because it started counting from index 5, which is this letter T. So 5, 6, 7, 8, 9, 10, 11. This is the S that it returned. We also have the possibility to say how far we want the search to go. So if I add a comma here and I add that third parameter, I want it to search up to character number 11. Well, now it gives me an error because although there are 3 S letters in my string, I asked it to search from 5, which is this T, up to 11, which we know is precisely this letter S. But here we have a learning curve. It is not inclusive. That is, the number you choose as the third parameter to indicate how far you want to go with the search, it will not be included. So keep this in mind when you build your searches. In our case, in this range from here to here, there is no S, and that's why it returned an error. Now let's delete our index method, because I want to show you another alternative which is actually a different method, but it is very similar to index. So let's put the dot here one more time, and notice that we have the rindex method. It's very similar, but the difference is that it searches backwards. That is, it searches from right to left. So if I put the letter S here, what it will do is it will search from right to left and it will return 17, which is this S, the first one it found. And it returns it with the index that goes from left to right, not with the index that would give me -1. Okay, so this is an alternative to doing searches with rindex. And that's about all for the index method, so let's keep going now because the day is just beginning. I'll see you in the next lecture.
In this lecture, we are going to learn another method for strings manipulation, which will allow us to extract portions of text In other words, you will be able to select a fragment of the string and store it in another variable. This operation is called slicing. This procedure is similar to the one we saw in the previous lecture to extract a character from its index. But if we now add a colon and a second index, always greater than the previous one, we will obtain all the characters that fall within these limits. The first number indicates the index where we will start extracting our fragment, and the second number indicates where our fragment ends, but doesn't include it. We can also include a third factor that allows us to set how many characters our snippet will select. We'd better go to PyCharm to see all the variations of this trick.
And now from PyCharm we're going to learn the different variations for slicing our strings. For that, first we're going to create a variable called text, in which we're going to load a string that is composed by the letters of the alphabet, up to M. We're going to do it in capital letters so that they are better visualized, and we're going to choose to do it with the letters in order so we can see easier for you to understand how it works. Now we're going to create a second variable that is going to be called fragment. This one will contain our text. But let's add the square braces with the index 2. You already know how to do this, but follow me and let's print our fragment. If I run this, we come to run, and we choose slice, which is what the file is called. And here we have a capital C, which is index 2 of our string. Perfect. Now let's start with the variations. I already know where I want to find my character, but what happens if I add here a colon and then, for example, the number 5? What I'm doing is saying I want you to extract all the characters that go from index 2 and up to, but not including, index number 5. So here we would have C, and then D would also come in because it was in index number 3. Next would follow the E, which is in index number 4, and the F would not do it as it's in index 5. And remember, that is until, but not including, this second factor. Then we could have C, D, E, and not the F. Let's see, if we run it C, D, E, right, that's how we extract a fragment or a slice of our strings. If you omit the second factor and leave just the colon, Python is going to interpret that you want to do it from index 2 to the end. Run it and see that this has extracted from C to M. It assumes that having the colon but omitting the second factor means as far as you can. If we do it the other way around, we're going to leave the first factor empty, colon, and we're going to say 5 as the second factor. Here it will interpret extract from the very beginning of the string, from index 0, to but not including index 5. We run it and we have A, B, C, D, E. Okay, so we have these first two factors. Let's write 2 again. Now we're going to make a second factor longer. 10 is okay. So we're going to get a longer string and then we're going to include a third factor, as Phil showed you in the introductory part of this lecture. This third factor is going to tell Python how many characters it should count from the previous one to extract the next one. So if I say 2 here, just to pick a small number, we execute it, and look what we've done. From index number 2 to index number 10, but not including it, it has taken the first character, counted 2 to choose the next one, and so on. So it took the C, it skipped the D, it took the E, it skipped the F, and it took the G. It skipped the H, and it took the I, it skipped the J, and it dropped the K, because that's index 10. I could have said 3 here, and this would make it skip 3 by 3, which leaves us fewer and fewer characters. Or, if we wanted to, we could leave the first and second factors empty. Then we say 3 here, and it will take all the characters that there are from the index 0 to the last one, but skipping 3 by 3. And a curiosity, if we put here a negative number, for example -1, and we execute it, we're going to obtain the whole chain, but in reverse. It is taken from the last number, and one by one it has been going by the inverse order until arriving at the A. If we put here -2, it would be the same thing. We would have the same reverse order, but this time skipping one at a time and leaving the next one. So that's all about slices of your string. Don't miss the practical exercises that follow, and let's go to the next lecture to continue learning the elements that will allow us to build today's project. See you there.
We already know two specific string methods, the index method, which allows us to identify at which index a given character is found, and the format method we saw yesterday, which allows us to format combined strings. In this lecture, we are going to quickly learn 6 more methods that are very simple to use, and they are upper for uppercase, lower for lowercase, split, which is used to transform an entire string into a list of words or set of characters, join, which does the opposite of split. It takes a list of strings and joins them together, but adding the separators of your choice. This is very useful and we'll see it in a minute. Find, which is very similar to index, but with a small difference we'll see pretty soon. And replace. This one allows us to replace parts of a string. These are just 6 of more than 30 methods that string has. It doesn't make sense to go through them one by one in these video lectures, since some of them are too specific or too infrequently used, but you'll find a list in the PDF notes next to this lecture containing all of the methods for strings that exist in Python in case you want to have it handy. Be sure to download it so you have it available if you need it. For right now, let's go to PyCharm and see how to apply these 6 methods in our code.
And now we are in the code, ready to see how these methods work. First, we're going to create the conditions in which we're going to work. We're going to do it with a variable that is also going to be called text. And this time it is going to say, we are going to learn 6 methods today. This is just an example. I missed the quotation marks here, so okay, otherwise it will not work. And we're also going to create a variable called result. And this variable is going to store the variable text now. But we will change that later. Now we're going to print result to see on the screen what we're doing. Let's execute this. And we see our text. We are going to learn 6 methods today. Excellent. What we will now do is to begin to apply methods. And we're going to do it here inside the variable result. First, we're going to know a method that allows us to transform all the characters of a string into capital letters. And this is none other than the upper method, which we can see if we press the dot and see the entire list of methods. I write the letter U to shrink it, and here I see upper and we choose it. As you can see, the methods are written with a pair of brackets that open and close, and this warns the system that we are working with a method. Many times these brackets are not going to have anything inside. It means that the method does not need more information to work, as in this case, in which I click and here I have, we're going to learn 6 methods today, all in capital letters. But you'll also see some methods that you may need to enter some parameters that allow you to determine how this method will work. Still, when you don't need to give the parameters, the brackets should be written always. Actually, if I take out the brackets here and we want to run this, as you see, it doesn't throw me an error. It's simply telling me now that what result has is a built-in method which is upper, and it belongs to the string object as this location. It just gives us some information, but it doesn't execute the method. It just tells us what result contains. If I put the brackets again, now it does. Another thing we can do, if given the case that we don't want, for example, to transform all the text into uppercase inside result, we can determine, as we saw in the previous lecture, a particular index. So, inside the braces, I will put the example, the index 4, and I'm telling it that the result will be equal to only the index 4, which in this case is the letter R, but in uppercase. And as you can see now, only the R is printed in a capital letter. Well, also, if there is a method that makes everything in uppercase, there must be another method to make everything in lowercase. This method is called lower. We execute it. And here we have that. We're going to learn 6 methods today, without the capital letter at the beginning, all in lowercase. So let's move on to another method, the split method. Split allows us to split our strings in several pieces, and it is going to save all of them inside a list. So if I execute this now, what I'm going to have is that the result is equal to a list. What is a list? We're going to see lists later and in a couple of lectures. But in the meantime, I want you to know that lists are a collection of items, and we store its content inside square brackets. And here we have then a list composed by all the words that are in my text. Now it's separated in as many elements as words have my sentence. We will see later how we work with lists. Don't worry about that now, but you can understand this for now. I also want you to know that what split does is to separate the elements, using the empty spaces as a separator. This is what it does by default, but if I pass a different separator as a parameter between its parentheses, for example I put here the letter O, now my list will be composed by all the elements that are formed taking O as a separator. Then the first group is we are G, because the next letter should be an O, and that's a separator. The next group says ing T. The next one, learn 6 meth, then DST, and finally day. So that's how you determine what the split criteria is going to be, and how groups will be created. Let's learn one more method. We've already seen 3. Now we're going to look at the 4th one, which is join. And join is the opposite of split. We're going to create something different down here. We're going to make a couple of variables. The first one is going to have the text learning. The second variable is going to have the text Python. And the third variable will be is. And the last variable is going to have amazing. As you can see, I chose 4 words that can form a sentence, and now I'm going to create a 5th variable, the variable e, to which I will simply generate the space that I want to be used to join all these words that would be separated by a space. So e equals a space, which is also a string, and I apply join method to it. What is join going to do here? Let's open the parenthesis, and it's going to take all the elements that we include inside the parenthesis, and it's going to separate them with a space. Of course, the elements that must go inside the parenthesis have to be from a list. Since you don't know how to handle lists yet, I'm going to build a list from the elements we have here. We simply open the square brackets, as I told you the lists go in square brackets, and here we're going to put A, B, C and D, which are the 4 elements that I have here. Here I'm creating a list with 4 elements and I'm joining them with a space between each one of them. Now I ask Python to print E, and we run it. The first line doesn't matter, it's from before. But here you can see learning Python is amazing. This has been formed from print E, which has here the union of spaces with the words. If I change this space to something else, for example hyphen and print it, well, learning hyphen Python hyphen is hyphen amazing. So it's a very simple thing to do. Still, any questions you have, remember you can ask your questions here in this lecture and we'll answer them as soon as possible. Let's get this out of the way, and now we're going to look at 2 more methods. The penultimate one is find, and this is not going to be new to you at all because it's exactly the same as the index method, which we've already seen in the previous lecture. Well, find does that. It looks for a certain character inside my string. So here I put, for example, the letter S, and it's going to look for it and it's going to find it inside the index 22. You may be saying, okay, why then we have find when we also have index? Well, the only difference between these methods is this. When find doesn't find the substring in your string, as for example Q that does not exist in my string, and execute it, instead of giving me an error, as index would do, it just gives me the value -1. So when find does not find what you're looking for in your text, it will turn -1. And finally, we have one more method, which is the replace method. As you can imagine, this method serves to take a fragment of your text and replace it with another one. This method, of course, needs parameters. In fact, it needs 2 parameters. The first is the text that I want to remove, let's say 6. Then the comma to go to the second argument, which is the case is going to be a lot of. And if I run this, it's going to tell us that we are going to learn a lot of methods today, which is also true. And let's suppose now that I want to replace all the E letters by X letters. If I do this, I'm going to get this impossible to pronounce sentence. Well, this has been all about the most frequently used methods that we're going to use throughout the course. Remember that there are many more methods. Some are too specific, we will hardly use them, but some may be useful to you. I recommend you download the notes that come with this lecture so you can have them handy and know everything about strings. Now please do the exercises below and we'll move on to the next lecture to continue growing and learning.
Now you understand the string methods, but in order to finish learning everything about strings, we need to learn a bit more about their properties. First of all, strings are immutable, which means that once they have been constructed, you cannot change their internal order or alter their contents. Maybe it's confusing because you have already been able to extract substrings from a larger string, alter their order, and even replace part of their content with another one. But keep in mind that we have done all this by using other variables where we applied the transformation and even by rewriting the same variable. Remember that we are not talking about variables because they can vary. We are talking about the string itself, which is immutable, and we will check it in the code in a moment. Another feature of strings is that they can be concatenated. We have already checked this by using the plus sign. And we're going to link that with the next property, because if we use the asterisk sign, we can multiply strings. We'll also see that in the code and you'll be surprised. On the other hand, strings can have more than one line, but I don't mean using the backslash and the n as we have done so far. Instead, at the moment of creating the string, we will do it using 3 opening and closing quotes. They can be double or single, and that allows you to make line breaks directly with the enter key. Another thing you can do with strings is to check if a given substring is inside its content, and Python will tell you if it is true or false. Finally, you can calculate the length of a string, how many characters it has, using the len function that we will also see in the code in a moment. Actually, let's not delay anymore. Let's go to PyCharm right now to learn.
And here we come to PyCharm and we're ready to see these string properties in action. Let's start with a situation where I have a variable called name. And the name in this variable is Harry. But then I found out that Harry is not really Harry, but Gary, with a G. Then I propose a method to replace the content of this variable to transform the H to a G. Then I say, well, I can make name at its 0 index equal to the capital letter G. Now I want to print name and see how it has changed. Let's go to run and let's go here, let's choose this file called properties, and I get an error. And pay attention to what the error says. It's a type error. It tells me that string objects do not support item assignment, and this is fundamental. One of the properties of strings is their immutability. As Phil told you in the introduction of this lecture, neither their contents nor their order can be changed. Of course, you have seen that throughout this course we have done things like rewriting a variable. So here I can say name again and I write Gary. And this has not given me any problem. It is going to let me do it. I execute it and see it changed. But let's not get confused. What I changed here is the content of the variable, because the variables can vary, but the string has not changed. Now I've created a new string that I've hosted in the same variable, and now it shows me the string Gary with G, but the string Harry I wasn't able to modify in any way. The next property, we already know it. Strings can be concatenated. So if I have, for example, the variable n1 that says GA and the variable n2 that has content RRY, now I can create a concatenation of variables that is n1 plus n2. And then I print this. We're going to see here Gary in a concatenation of 2 strings that were transformed into one here. I could have even housed it in a new variable that contains this concatenation. Now this we already knew, but let's queue this up for the next property, which is that strings can be multiplied. You know that we can use the plus sign to concatenate. What happens if we use the multiplication sign? We're going to put this asterisk after n1 and we're going to put the value 10. If I run this, we have GA, 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 GA repeated up to 10 times, and you can do this because it's a property of the strings. Let's move on to what follows. Another thing that Phil told you a few minutes ago is that a string can contain several lines of code, and not necessarily through the spacebar and the N to indicate a line break, but write it directly by using 3 pairs of double quotes or 3 single quotes. And let's put this to the test with a poem. Poems, you know, sometimes require line breaks in order to be written. We're going to write it first, without quotation marks. We're going to write one that says, 1,000 little white fish. We do the line break and enter it as follows. as if boiled, enter the color of the water. This poem is a haiku type poem that belongs to Konishi Raisan, and it is short but beautiful. Let's select all of this. Let's press the double quotation marks once, twice, and 3 times. As you can see, now I don't get any errors. And if I want to print the poem, what I'm going to get is the poem in its 3 lines, as I expected it to happen. So this is another way to make line breaks in your strings. Let's see one more thing. I can check if a certain word or character exists in a string. If I do it here inside print, we're going to ask for the word water. Exists in poem, so I'm saying print the answer to the question, does water exist in poem? As it is a question that is answered with yes or no, this is a Boolean type data type. One that can only tell me true or false. Actually, when printing it, it's going to say true because water, it is found in poem. And if I were to look for sun, which is not found in poem, I will get false. I can also ask it if a certain word or character or whatever it is not in my string. I do this by asking it if sun is not in poem, and it will give me back true because it is true that sun is not in poem. If I look for water, which it is in my haiku, I will receive false because it is false that water is not in the poem. I hope you understand this logic of double negation. So these are the most important properties of strings. We're going to get to something new in the next lecture because we're going to get to the other types of data that we don't know yet. So let's get to it.
From this lecture on, all object types we have yet to learn are coming, and we are going to start learning about lists right away. A list is an ordered sequence of objects. Lists can be assigned to a variable, and their elements can be strings, integers, floats, or any type of object that we will learn about soon. A list can even be composed of objects of different data types. Lists are written in square brackets, and their elements must be separated by commas. It is also possible to nest lists. What is nesting? The same way we can have a list of integers or strings, we can also have a list of lists. Just like strings, we can index and split lists because strings actually work almost like a list of characters. Similarly, lists also have methods that allow us to manipulate and parse them. And unlike strings, lists are not immutable, so we can modify or rearrange their contents. There is a lot to learn about lists, so let's put our fingers to work in PyCharm right now.
Exactly, Phil. Our fingers are ready to start typing everything related to lists. So here we are, in a new file that I've prepared that's called lists, and it is inside day 3, and we're going to start creating a list. We're going to assign it to a variable called myList, and we're going to say that myList is equal to a list composed of data that we're going to put in square brackets. In this case, they're going to be a list of strings. They're going to be in quotation marks, and they're going to be the letter A, then the letter B, and finally the letter C. That is to say that this list is going to have only 3 elements. First, I'm going to show you what the data type of a list looks like. So let's print the type that corresponds to my list. Then we're going to run this by going to run, and within run choosing lists. And here we have that this object belongs to the list class. I also want to show you that we can create lists, as I explained before, that have different types of data. We're going to create another list, and we're going to say that it is equal, for example, to a string that says hello. This is the first object. The second object is a number, 55. The third object can be a float, for example. And as you see, this does not throw an error, and it allows us to continue with our code because lists in Python, unlike most languages, can contain objects of different data types. Let's remove this. That's it. I want to show you that we can apply here the length property, because the same as with strings, we could also know the length of a list. We can know how many elements a list contains. Then I'm going to say that result is a variable that is equal to len. That is to say, the length of my list. And here, instead of type, we're going to print result so we can see what it contains. And it tells us that my list has 3 elements. Amazing. You can also extract the value of one of those elements using index. We can index lists as well. So I'm going to say that the result is equal to my list at its 0 index. And if I run this, I'm going to see the letter A, which is the element that it has at index 0 of my list. Just like strings, indexes in lists start at 0, 1, 2, and so on. Everything we've seen about indexes on strings applies to lists. If I also want to search, for example, the indexes that go from 0 to 1, in this case 0, 1, we have here only one object because remember that it goes up to 1 but does not include it. But if I put 2 here, in that case I can see element 0 and element 1. Element 2 is not included. If I leave this empty, I can see from the beginning to the end all the elements. The same as with the strings. We can also apply what would be the concatenation of lists. We have seen it with the strings, so if I create my list 2 and I say that this list is equal to, let's say, D, E and F, now we have 3 more elements in a separate list. But if instead of result now I print my list plus my list 2, we're going to get a concatenation that gives us a single list that is A, B, C, D, E, F and has joined them all together. But remember, the original 2 lists still exist. If I print just my list here and then also print my list 2 and run it, the 2 original lists will still exist. What I have done before was to print them together. If I wanted the 2 to exist in a single list so that I could use, what I would have to do is create a third list. This is going to be my list 3, and it's going to be equal to my list plus my list 2. And here we're going to print just my list 3, which is the one I just created. Let's see what it looks like. Well, same as before, but now I have a variable that is my list 3 that contains the concatenation. Well, this would be the basics about lists, and it applies to almost everything that we have seen about strings, because the strings in some way are a list of characters, although this technically does not apply to all of the sense, but they work quite similar. Now there are things that strings can't do that lists can, like alternating their elements, and we're going to see that next. We're going to allow this my list 3 to continue existing, which is the one that has 6 elements, and we're going to eliminate this line with the result, and we're going to do what we've wanted to do with the strings before, and it gave us an error. We're going to say that in my list 3, in its index 0, we're going to overwrite it only to that index, and we're going to say that now instead of A, it is alpha, and we're going to go to print my list 3. Observe what we have now. We have alpha, B, C, D, E, F. With strings I could not do this, but with the lists I can overwrite any of its elements. And we also have methods to do many things with the lists. Notice if I put the point after my list, we can see all the methods that correspond to the lists coming. And we're going to look for this one that is called append. As its name suggests, append is used to add an element to our already created list. Let's add G, which will be the one that follows alphabetically, and let's execute my list 3 to see how it looks. Okay, now we have A, B, C, D, E, F and G. If you're wondering why I no longer have alpha, note that I deleted the line that did the operation and rerun a new instance of all of this so it cleared up what I did before. But now we have then not 6 but 7 elements. Because lists, when you add an element, this will not be a concatenation. This is adding something to the original list. So I did not have to create a new variable as I have necessarily done with the strings if I want to modify them. Here the source list was modified, and just as I have a method that allows me to add items, I also have methods that allow me to remove items. We are going to invoke again my list 3, and this time we're going to apply a method that is called pop, and through it we're going to remove one of the items from our list. What pop does, if you leave it without parameters inside these parentheses, is to interpret that you want to remove the last of its elements. Then we're going to eliminate this G, so that we have our original list from A to F. See? And now we're going to eliminate the last element that is F. We execute it, and A, B, C, D, E, and the F is no longer here. I was telling you that pop automatically interprets that you want to delete the last item, unless you specify here which index you want to delete. If I set it to be index 0, then let's run it again. This time it deleted the first element and I start with B, C, D, E, F. There is also a way to store that element that you delete in a variable in case you want to manipulate it or use it. We're going to repeat this operation, but storing the popped element in a variable called deleted. And what we're going to print now is not only my list, but we're also going to print deleted. Let's see what it looks like. So we have the list without the initial element. Already removed the popped element here in the index 0. And apart we have printed the variable deleted, which contains the element that we have removed. That is to say that you can also remove them and reserve them to use them in the future. As you have seen, there are many methods to use with the lists. We're going to learn some of the most important now. Let's get to know one that allows us to sort the lists. Suppose I have a list here that is equal to alphabetical elements, but out of order. We're going to do the G, we're going to do the O, and we're going to do a B. We can do an M, and we can do a C. Okay? These are elements that are out of order. Now I'm going to call list. I'm going to apply a method called sort, and we're going to leave these parameters empty. And we're going to print this list now. Let's see what this looks like. Our G, O, B, M and C are now B, C, G, M and O. That is to say that they are all in alphabetical order. And the same thing would have happened if I had put numbers out of order or if I had put people's names. It sorts them alphabetically. What you do have to keep in mind is that sort is a method that works in place. That is, it reorders the list itself, but is not a method that returns anything. Many times a beginner might think, well, there I can do this, I can store my list in a new list and it's equal to the sorted list, and then I will print a new list and this is going to give me my sorted list. If we follow our intuition, we would think that this would work, but run it and our list is not there. It's not even sorted or unordered. It tells us none. And this is where it's important to understand the logic of this. Actually, to help you understand it better, I'm going to type here to find out what type this new list object that we have here is. And Python says that it's a non-type class. That's the data type that contains new list, which we've supposedly assigned our sorted list to. But instead of my list, we have this non-type. A non-type is the data type of a non-object. Let's see it in basic English. We could say that Python created the non-type object to indicate an object that has no value, which is not the same as having a zero value. Zero is something, it is not the same as having no value at all. In a nutshell, none is the result of an object that does not return anything. The important thing to understand here that sort is a method that performs an action, which is to sort the elements but does not return anything, and therefore we cannot assign that non-return to a variable, which is what we wanted to do in this case. Maybe this is a little confusing for you now, but the important thing to understand is that there are methods that simply do something, but do not return information that you can store elsewhere. So if I want to see my sorted list, I simply perform the execution and then I can see my list that has now changed and is sorted, and I can see it this way. If I wanted to store it somewhere, I have to do it separately. I store my modified list in list 2. Now I print here list 2, but this would basically be a redundancy because now I have two lists that are the same. Finally, one more method that I want you to know is the opposite to this method that allows us to sort alphabetically. This one will sort it backwards. We have a method called reverse. Let's look for it here. List point. Reverse, here it is. And what reverse does is it reverses the order. It puts the last thing first and so on. In fact, if we print it out, we can see that now our list is in alphabetical order, but it goes from Z to A. And that's what reverse has done. Like sort, reverse does not return anything. It transforms it in place and we can't store it directly in another variable because it will give us a non-object. Well, this is the most important thing to know about lists. So be sure to download the notes to have everything organized and visually accessible to you, and be sure to do the practical exercises that follow. And then move on to learn the next type of data that are dictionaries. So I'll be waiting for you there.
To understand what the dictionary type objects are in Python, let's think about real-life dictionaries. Open a dictionary at home and you'll find a collection of unique concepts. For example, all the English words. Next to each concept there is a definition. So ultimately what you have is a bunch of pairs, which are composed of a concept or keyword and a value associated with that key. In Python, it is more or less the same. A dictionary is a collection of pairs, and each of those pairs has a key and a value associated to that key. Moreover, keys, just like in real-world dictionaries, cannot be repeated. They are unique. How do you write a dictionary in Python? Between braces, and each pair of elements is going to be separated from each other by commas. And within pairs, the key and its value are separated by colons. Unlike lists, dictionaries do not have a specific order. They do not have an index. Therefore, even when you create them by writing them in a certain order, that order will be irrelevant for Python. Dictionaries could well be written the other way around, since you cannot look up a value based on its index, as we did with lists. You can look up values based on its key. So when is it convenient to use lists and dictionaries? For dictionaries, we said order does not matter. So you cannot sort with the sort or reverse methods. But the relationship between a key and its contents does matter. So a good occasion to use a dictionary is when you want to store values that you can access without knowing the exact location, but the relation with another concept. For example, when you want to store the characteristics of a person, which you can then access by consulting their weight, size, name, regardless of the order they are stored in. In order to better understand this, let's see it in action.
And we put ourselves in action right now to see these dictionaries in PyCharm. We're going to begin declaring our variable. As always, that is the one that is going to contain our dictionary. Our variable is going to be called myDictionary. And remember, the dictionaries are written between braces. And what we do here is to declare first a key and then a value. For the first key, I'm going to say C1. And as I've chosen a string name, I have to put it in quotes. Then a colon to associate it to a value, and in this case, let's keep it simple, with value 1. And I also want to put this in quotes because it is a string value. This is the first element of my dictionary, and this could be a complete dictionary, but let's add another one. We're going to add another key, this time called C2, and we're going to associate this with an element called value 1. So this is my first dictionary. Now let's print out the data type that corresponds to my dictionary. We're going to come up to run, and run again. We choose the file Dictionaries, and it tells me that this dictionary element is a data type dict, which remember is short for dictionary. So alright, we have a dictionary, but now we're going to print it out to see its contents, not its type. So we delete type, and we run it again, and we see all its contents. We see between braces that it has C1 with value 1 and C2 with value 1. Okay, I repeated it. I wanted this to be value 2. By the way, I take this opportunity to show you that although the keys cannot be repeated, they have to be unique. Otherwise, it would be complicated, and when you want to find a key that is written twice. The values can be repeated as you just saw. The values can be all the same if you want, or they can be 2 or 3 that are the same. That is indistinct. The keys are the ones that can't be repeated. Alright, let's move on. Now let's see how we can query what's in one of those keys. Let's suppose that I need to fetch the contents of key 1. In that case, let's create a variable called result to store our dictionary, but only whatever there is in C1. I'm no longer invoking an index number here, I'm invoking a key. And what this brings me, if I now print result, is value 1, which is the content of C1. Okay? If I'd searched here for the contents of C2, what do I get is value 2. And that's how you do your searches. Now let's focus on some kind of real life case. Suppose I have a variable that is called customer, and I want to store it in a dictionary with all the characteristics or categories that I have about this customer. Then a key could be name, and a name is going to be associated to a value that can be John. We're going to have a second element that can be last name, but well written. That is, and we are going to associate this to last name. John can be Lennon, and we're going to give it more categories. We're also going to give it a weight, and a weight can easily be a value of or type of integer, because dictionaries can have all kinds of data. So we're going to give it an integer, and here we don't need quotation marks. We're going to add one more value, and we're going to put height here. This allows us to incorporate a float value. Let's say 1.76. Okay, here we have a dictionary called customer, and now I want to make a query. Let's make a variable called query, which contains a value that I want to look up. So I want to know the last name of my customer. So what I put here is customer in the location of whatever it is in the key, last name. And then that's what I'm going to print. I'm going to print query. Let's look at it. Here we have Lennon. Perfect. When I asked to query whatever is in the key last name, I received Lennon. And if I'd asked to tell me whatever it is in the height key, I would have received 1.76, which is my client's height. Well, as you can see, dictionaries contain different types of data, not only in their keys, but also in their values. And they cannot be integral strings or float, but also all the data types that we have learned and that we have yet to learn. A dictionary can contain lists, or it can contain dictionaries inside the dictionary. Let's create a new dictionary. We're going to call it Dick, and we're going to put a little bit of everything in it. The first Q will be 1, and it will contain the integer 55. Okay? Then we're going to put a list. The key 2 is going to be equal to a list that has the numbers 10, 20 and 30 in it. And it supports it. There's nothing wrong. Comma to come up with a third value. And actually will be another group of elements. It will have the key 3, and we're going to write a dictionary here. So we make the dictionary keys, that is S1, that has the value 100, and a key S2 that has the value of 200. And this dictionary is the value of the third key, which a dictionary with 2 values in it. That's perfect. What a mess when we want to query this. Let's see how it would work. If I want to print my dictionary, but only what's in the key 2, which is a list, key 2 is a list, well, if we print it, we get the list. And let's suppose I want to query only what's in index 1 of this list. Then I have to add, after I close the braces of the key, another bracket in which I'm going to put index 1, which is the one I'm interested in searching. So here I'm saying, please Python, print whatever it is in the dictionary in its key 2. And within that key 2, whatever is in index 1, because I know it's a list. So if I print it, I only get 20. So my searches can be very specific. And now I want to search for what is in key 3, which is a dictionary. Let's delete this key. We're going to obtain the dictionary that is inside my dictionary, which is this one that has 2 keys. And if I want to look for what is in the key S2, then I add a bracket, and I put S2 here, and I print it and have 200. That is, I can look up what is in the dictionary within any other dictionary. Well, this would allow us to do an exercise. Here I have this dictionary prepared so you don't have to waste time watching me type. We're going to paste it in here. We have a dictionary that has a key 1, which is a list, A, B, C, and a second key, which is key 2, which has another list, D, E, F. What I'm going to ask you now is that you try to make in a single line of code, a command that allows the letter E to be printed on the screen, but capitalized. So take your time, pause the video if you need to, and try to do it. If not, don't worry, we'll do it together. Well, if you were able to do it, congratulations. And if not, don't worry. Things can get messed up easily when you're learning something new, and we're going to do it together now. We're going to do it in steps, so we can think it through easily. First, we're going to print our dictionary directly through the key. That's the one with the E. We said it's key 2, so we're going to print out key 2. Okay, let's go through the steps. So now we already have the list that contains the E. Now I want to print E, so I add a bracket that looks for the index that corresponds to E, which in this case is 1, because D is 0 and E is 1 within this list. So we put 1 here. If we print it, now we get the E. And now I want it to be capitalized. Well, this is the part that may have cost you a little bit. Remember that the E is in a string, so we have a method to make a string become uppercase. So once we've built this whole statement, then we put the dot because we have a string. And here comes the string methods. And what is the method that we use? Well, it's upper. Remember, it has to go with its own parenthesis, and if we run it, here it is our uppercase E. It was easy, but of course knowing how to do it is what may cost you a little bit. If I wanted to print the uppercase A, well, I would just choose key 1 and within key 1 index 0. And then I print it here, I have my capital A here. Well, let's learn a few more things. I want you to learn how to add items to a dictionary that's already been created. So let's create a dictionary and we're going to fill it with something simple. A key 1 with value A and then a key with value B. Okay, so we have a dictionary here with 2 elements. We're going to print it out and we have our 2 elements. Now I want to add key 3 that has a value of C. I simply invoke dictionary. I invoke here a key that doesn't really exist, but I create it at this moment. It's going to be 3, and since it doesn't exist, what I put here in equals is what's going to be added as a value. And what its value to be C. So now I go back to print to our dictionary and we are going to obtain that now we have 1A, 2B and 3C. Our dictionary has been able to be modified in situ, that is, in place. We have not had to create a new variable to contain our modified dictionary, but the DIC itself is now the one that has its modification. This, like lists, means that it is possible to modify them, unlike strings. I can also overwrite a value that already exists. Suppose I now want my letter B to be uppercase. Well, the way to overwrite it is to invoke a key within the dictionary, in this case the key of B, which is 2. And what I do here is to assign it to a new value, which would be in this case B. As this key 2 already exists, it is not going to create a new key inside my dictionary, but is going to overwrite the one that already exists. So we're going to create a print to be able to see this third instance of my dictionary. We run it and we have here 1A, 2B and 3C. Okay, that's the way to overwrite. So a couple of other dictionary methods you might be interested in learning. Suppose you want to know all the keys that are in a certain dictionary. Well, let's print out our DIC. Let's press dot to bring up its methods. And the keys method is the one that is going to bring us all the keys that it has. If we print it, we see here that dict keys is 1, 2 and 3. It did not bring us the values, only the keys. So if I wanted to know the values, then I print dic.values. So here we get them. Dict values A, capital B and C. These are the actual values in my dictionary. And if I want to know everything that is in a dictionary, then print dict.items, and this is going to bring us everything that is here. Then dict items is in parenthesis 1A, in parenthesis 2B, and in parenthesis 3C. The fact that they are in parenthesis gives us a guideline that what is inside the dictionaries is something that is called tuples. And tuples is what we're going to learn in the next lecture, where I'll wait for you after you've done the practical exercises that come next. So let's go to the next lecture.
The tuples are a collection of elements that is very similar to lists, but with one important difference. They are immutable. Once an element is assigned to a tuple, it cannot be changed or reassigned. They are written almost the same way as lists, but they have parentheses instead of brackets. And you can also write them without enclosing them in anything, and they work the same. Okay, but if they are so similar to lists and even more limited than lists, because tuples are immutable, why would we use tuples instead of lists? Mainly because they take up less memory space and therefore are faster to process than lists. Secondly, since they cannot be modified, we may use them to store structures we do not want to be modified. They would be damage proof. Let's move on to PyCharm and Federico and see tuples in action.
And to see the tuples in action, we're going to come to PyCharm and we're going to start creating a first variable called myTuple. That is going to have as a content a very simple tuple with the numbers 1, 2, 3 and 4. Remember, between parentheses and separated by a comma. And now if I want to print to see the type of this object, we're going to print here. Type, my tuple, and we're going to execute it and going to run. To the second run, and now we choose tuples. And we can already see that this is a tuple type class. And as Phil explained in the introductory video, we can also do it directly without the parenthesis. If I do it this way, we still have an object of type tuple. However, the most common is with the parenthesis, but you can build them as you want. I also told you that we have tuples that contain all kinds of objects. Here I have built a tuple that has only integers. But tuples can also have any kind of object, even objects of different values mixed in a single tuple. Let's create a simple one called t, which will contain an integer, then a float, then a string, and so on. It could even have a dictionary, it could have a list or a tuple itself inside the tuples. In fact, we're going to see that in a moment. But now I want to show you that I can also query that what is in the given index. As we did with the strings, this can also be indexed and sliced. For example, my tuple at position number 0, I want to print that out of this is going to tell me that position 01 is found. Right, that's the first element of my tuple. I can also search with negative numbers that, just like strings, makes it count from right to left. And the -2 position would be 3. It should give me a 3 here. And it does. Indeed, return a 3. Mind you, tuples are immutable, just like strings. So we cannot do things like changing one of the elements inside the tuple that we already have. Of course, we could do it by creating a new variable. If what I want to do here, for example, is to say that now my tuple is in position 0, I want it to be equal to 5. And now I want it to print my tuple, and I print it. Well, it's going to give me an error that says it's a type error. The tuple are objects that do not support item assignment. The same as the strings, remember? Well, since we saw this error, we eliminate it then. We cannot continue this way. And we can do other things that can be done in the lists and be done in the dictionaries, which is nesting. I can have, for example, inside my tuple, one or more elements that are tuples themselves. Suppose that here, instead of having my integer at index 2, I have a tuple that contains the numbers 10 and 20, so to speak. Is that okay? Now if I want to query what's in my tuple at position 2, let's print. It's going to tell me that that position I have at tuple containing 10 and 20. And if I want to consult the first of the objects inside that tuple, then I have to look inside position 2, and then in that position in the index 0 of that tuple that I have there. And then it will return only the 10. Is that understood? You can do it the same way as we've also seen with the lists and the dictionaries. The other thing that we can also do with tuples and lists is to do castings. If I want to transform my tuple, we're going to overwrite it. We're going to write again my tuple, and I'm going to save it this time as a list. So I say list, and in parenthesis I put my tuple. And now if I want to just print out the type of my tuple to see what's happened now with this. Let's close this in parenthesis and print it out. It tells us that it's a list type class. Although I created it as a tuple, then through a casting I put it inside a list. And now if I come back to overwrite again, my tuple, my poor thing, and this time I put it inside a tuple that has a content what is in my tuple. Now the class type is tuple again. We've gone around a couple of times. Well, you can also do things like assign the content of a tuple to different variables. Let's say I have a tuple that's called t, and it has 1, 2, and 3. It has 3 elements that are all integers. And now I want the variables x, y, and z to be equal. That is, to have in their content whatever is in t. So far, notice that I don't get any errors. Let's see what happens if I print x, y, and z. It returns 1, 2, and 3. X contains the 1, Y has the 2, and Z has the 3. This could be done because we have the same amount of values and variables, so they were assigned one by one with this simple process. And I did not show this before, but I could have done it with the lists and also with the dictionaries. Of course, the condition is that there are always the same number of elements. If I had put here that I also have the variable a, and I want to print this, it will tell me that there is a value error because there are not enough values to unpack. We are expecting 4 because we have 4 variables, but I have 3 values. And if I had one variable less, let's try it this way. It would give me a similar error, value error. It tells me that there are too many values, this time to unpack. I was expecting 2 because I have x and y, and I have 3 values. Well, you can do this, we said, with lists and with dictionaries, as long as the number of values and variables match. Let's try one more thing. We have here this tuple that has 3 elements. We're going to add one more, this time a 1. I'm intentionally adding a repeated value. We're going to do 3 things. First, I asked Python to tell me what is the length. That is, the number of elements that our t has. So here in the impression, we're going to ask it to print the length. Remember, it is len. We used it with strings and lists. And the length of t. If we print it, it tells us that it's 4 because it has 4 elements. But now I'm going to ask a different thing. I'm going to use one of the 2 methods that tuples have. We're going to put the dot so that it brings us the methods. These 2 are the methods that you have, index and count. So let's start with count. I'm going to add it, but this method asks me for a parameter inside the parenthesis, which is a value. What it's asking me is what value do I want to count inside the tuple to know how many times it appears. Well, I want to know how many times it appears the number 1, and if I execute this, it will tell me that it appears twice. So the count method allows you to count the number of occurrences of a value within your tuple. And if I use the other method, that is index, and here we have it. I will say inside the parenthesis, which is the value on which I want to consult its index number. Well, let's look up the value of number 2. In what index is it? It will tell me number 1, and that's okay. Well, we can also do this with the lists, and the count as well. Okay, this would be all the basics about tuples. Don't worry too much about it for now, because tuples are not a type of object that you're going to use very much, or often at the beginning of your career, even at the beginning of this course. They're going to get a little more prominence later on, but they're not one of the most popular data types out there. We're going to do a couple of exercises now to get these learnings locked in for you, and then we'll see you in the lecture about set, which is the last of the elements or collections of elements that we have yet to learn. See you there.
In Python, sets are collections of elements, just like lists, but with some key differences that make them very particular. Sets can be declared in 2 ways, using the set keyword and then putting your elements in parentheses, or directly using the keys without using the set keyword. Although the braces are the same ones that we use to declare dictionaries, Python will recognize that it is a set because its content will be different from the one used in dictionaries. So to write its elements, which let's say is what this is right here, pay attention because there are 2 ways to do it. If you created your set using the set word and parentheses, the set will only take a single argument. So you must put all your elements inside braces. They can be parentheses, square brackets, or curly braces. It doesn't matter, but they have to be enclosed so that Python reads them as a single element. If you created your set directly with the set word and with curly braces, then you can put all your elements directly. The most important feature of sets is that they support single elements. In a set, elements are not repeated. And what happens if you do add repeated elements, Python simply discards the duplicates without asking you and leaves unique values. Another feature is that set elements are not sorted into indexes, just like dictionaries. While you see the elements displayed in a particular sequence, you cannot index them, rearrange them, or anything related to their internal position. And another issue is that elements are also immutable. All of these characteristics imply that although you can store elements of different data types in sets, you cannot include lists and dictionaries, so keep this in mind. I think it's time to see this in action and other details about sets over in PyCharm.
And now, from PyCharm, we're going to learn how to use the sets and all its alternatives. First, we're going to declare our variable, mySet, which is going to contain a set that we're going to declare using the first approach that Phil explained to you in the initial video, which is with the set word, then the parenthesis that opens and closes, and inside here we put our values, inside some other set of braces. We're going to do it in this case with the brackets, and we're going to create 1, 2, 3, 4 and 5. This is already a set, and to check it we're going to print the type of my set, and we're also going to print my set right now to see everything together. We're going to run this from the second run, and we're going to choose sets, and here it comes. First, this class is a set, and our set looks like this, with curly braces and 1, 2, 3, 4 and 5. As I told you, we could have done this with other kinds of braces, and it's going to work exactly the same. We could have done it with another pair of parentheses, and it's going to work the same because the idea is that within a set you should include a single argument. So look what happens. If I write it without any parenthesis, brace or anything, when I want to execute it, it tells me, hey, type error. Sets expected at most one argument, got 5. Then it doesn't want 5 arguments, it wants only 1. For that reason, we're going to pass it with some type of braces. And now PyCharm stops screaming. Well, this is one way to compose it. The other one, and we're going to do it with another variable that's called otherSet, is without doing it with the set word, but directly with the braces, where we write 1, 2 and 3. We're going to leave it like that. We're also going to print it so you can see the type of otherSet, and we're going to print also otherSet so we can see what it looks like. And here we're going to see this too. A set that is 1, 2, 3, 4, 5, and another set that is 1, 2, 3. So it is indistinct, and you can create it as you like. So we're going to eliminate this second one to continue working with the first one. And as we've said, this collection called set does not have an internal order. So let's see what happens if we want to look for another element. Through a print statement, I will show my set, but only whatever is in the index 0. Well, we want to run it, and it's going to tell me type error. Set objects are not subscriptable. That is to say that you cannot make this type of trick. Neither can you, for example, modify some of its elements saying my set in position 0. I want it now to be equal to 5. You will not want to do it, but it will also tell you that the set objects do not support item assignment. So you cannot do this with sets. So what can we do with sets? Let's see. I told you that sets are unique elements, therefore they cannot have repetitions. If I've created a collection here that does not repeat, it's alright. But if I had elements that repeat, for example, let's put more 1s or a pair of 2s, and so on, let's see what happens when we execute it. Notice it doesn't give me an error, it keeps telling me that this is a set, no matter how many repeats it has. No problem. But Python has removed all the repetitions. It has discarded them and told me that this set only has 1, 2, 3, 4 and 5. And it doesn't matter how many times you want to add some repetitions. That's why I can put integers here. I can put floats and I can put strings. But what I cannot put are, for example, lists. So watch this. If I want to change this 5, and instead of being a 5 to be a list with 2 and 1, so we're going to execute it, and it's going to tell me that there is a type of error. The list types cannot be mixed within a set, therefore this list element is not supported in sets. It will be the same with dictionaries, but it is going to support tuples. Actually, we're going to create one here, and we're going to create a tuple that has 1, 2 and 3. So the object that's here, in this place, all of this is a tuple. And if we run it, my set includes 1, 2, the 3, the 4, and then the tuple. You may wonder how it supports tuples and not lists or dictionaries, because tuples are immutable. That is, they are unordered, and the set requires that its elements are unordered and immutable. Therefore, lists and dictionaries cannot be included. Is this understood? Well, let's simplify this a little bit. We've got a lot of stuff here, so we're going to leave it at 1, 2, 3, 4 and 5. We're going to print it out so that it cleans up what we have. And I'm going to show you that you can also do things here like use the len function that we have had before to know the length of a collection. So we can say len, and we're going to put in the parenthesis my set. We're going to print, and it's going to tell us that we have a set of 5 elements. It has been able to calculate them. So you can also make queries like we did with strings, remember? Now I can find, for example, if 2 is in my set by asking it to print if 2 is in my set, and this should work by giving me a value that is true, because it is true that 2 is in my set. We didn't really see this before, but you can do this with both tuples and with lists, dictionaries as well, as long as what you're looking for in the dictionaries are the keys. Let's reset all of this to look at a couple more things. Let's learn a way to do set joining. Let's say I have a set that's called S1, and to keep it simple it has 1, 2 and 3. Then we have a set called S2 that has 3, 4, and at 5 I intentionally put a repeated number. Now we're going to create a third set. This is going to be called S3, and it's going to be equal to S1. But we're going to write a point to bring a method that is called union. And inside we're going to put what we want to join it with. Well, we're going to join it with S2, and we're going to print S3, which is the one that contains the union. We execute it, and now we have a set with 1, 2, 3, 4, and 5. Maybe you should have expected this to have a set with 6 elements, because there are 2 sets of 3 each. But as one of them is repeated, Python removed it and we have 5 elements. Do you follow me? Well, let's get to know a little bit more about the set methods. So here let's leave the first one, which is S1, and let's try the add method. So here we write the line that says s1.add, and inside we want to put what element we need to add. Let's say I want to add a 4 because I have 1, 2 and 3. Well, we execute it and now we have 1, 2, 3, 4 in our set. It can also happen that you want to add an element that you already have. Let's add a 2. Let's see what's going to happen here. Is it going to give me an error? What is it going to do? No, it simply runs the code and also allows me to do it. It doesn't give me an error, and at the same time it doesn't add it because it already exists. So what can we do as well? If we can add, we can also delete. So to this set that has 1, 2 and 3, we're going to apply the remove method. So what are we going to remove? 3, which is the last one. Now it's going to remove, and we have 1 and 2. What happens if I set it to remove an element that it does not have? We're going to ask it to eliminate 6. Well, it will give me an error because 6 is not there. It cannot be eliminated. For that we also have another very similar method called discard. That is not the same as remove. Well, it works exactly the same as remove. The only difference is that if I ask it to discard an element that does not exist, it will not give me an error. It will simply go ahead as if there was no problem here, because there is not. Actually, discarding is not the same as deleting. As it cannot discard 6, well, we move on. One more method, one that we have already met when we've talked about strings, is the pop method. Do you remember this method? If we leave empty in the parameters inside the method, it will remove one of its elements. But since here in set we don't have any order, remember we are seeing them ordered in capricious sequence, pop is going to eliminate a random element in this case. So pop can be very dangerous. But hey, sometimes it can be used to do a sort of draw, because you can contain the removed element inside a variable. For example, draw. Let's make it like that, and we're going to print draw. Well, we execute it and we get number 1, but we could have got any other because it has a random element. The last method that I'm going to show you, so let's put S1 again, is clear. What does clear do? Well, what it does is, if we leave it empty here, is it empties our set. So now our set has absolutely nothing. Well, there are many more methods that actually are not so frequent to use. They're quite specific, but if you want to know them, I will provide them in the downloadable PDF that you have next to this lecture. There is a file within the notes, and there you will find the other methods. So you can try them for yourself, and if you have any questions, please leave them in the Q&A area, because we are here to help you. So this has been all about the sets, and please do the practical exercises that follow, and let's go on to the next lecture. We have one more element left, another type of data that is not really a collection like the ones we've been seeing so far, but they are the Booleans, and you want to know them because they're very important within programming. So see you in the next lecture.
Like every programming language, in Python there is a data type that is different from the others. And although it is perhaps the simplest of all, it is one of the most important. Booleans, or bools. A Boolean element can only have 2 values, true or false. To declare a Boolean, you simply write the name of a variable and assign it to the value true or false. That's it, you have a Boolean. You can also declare them indirectly. If you assign a variable with a comparison, either true, for example the expression 5 is greater than 4, or false, 5 is less than 4. This is also a Boolean, because what Python does here is to check if your comparison is true or false. The expressions that allow you to make comparisons are the symbols greater, less, greater or equal, less or equal, equal, or different. Whenever you construct a variable, use these operators. Its result will be a Boolean value, true or false. We have also seen that you can construct a Boolean when you ask if a certain value is found inside a structure, such as a list or dictionary, or if it is not found. So why do we say Booleans are important? Well, they're practically the basis of something exciting we'll see later, which is artificial intelligence. Booleans are what will allow our programs to make logical decisions based on whether or not a condition is met. For example, true or false, such as, is player 1 dead? True. Okay, so it's player 2's turn. Let's go to the code because this needs to be seen in action right now.
And let's go to the action and let's see how a Boolean looks directly in the code. We're going to write a variable that is a variable 1, and we're going to put it directly. We're going to declare it explicitly here that this one has a value of true. We're going to create another one that has the opposite value, which is false. These are the two values that a Boolean admits. Of course, this is in the open way to create them, because as Phil told you, there are indirect ways to generate Booleans. Well, let's see what it looks like. Once we run this, and that's the data of a Boolean. So let's do this for variable 1, and also let's print variable 1 itself so we can see its contents. Let's go to run, and again to run, we choose the file Booleans, and here it tells us that the type of variable 1 is bool. That is to say that this is a Boolean and that its value is true. Remember, we did it here in the straight way. Notice that it will always be a capital letter when you put a false or true. But if I want it to be in lowercase, you're going to see what is going to happen, and it's going to give us an error. It tells us that it has a name error. The name true is not defined, in the same error that we would get if they had a string without quotation marks, because actually is what we did. Python recognized with uppercase as a special word, but on lowercase it means nothing for Python. And here PyCharm is telling us, hey, I don't know this. So true or false, it has to be capitalized. So we're going to eliminate this and we're going to start by trying some other things. Now we're going to create it indirectly. We're going to create a variable called number that we're going to give a value of 5 is greater than 2 plus 3. We're doing an addition here. Here I'm saying that 5 is greater than 2 plus 3. And as we know, this is not true because 2 plus 3 is equal to 5. So let's also print the type of number, and also we're going to print number itself. So let's run it, and it says that there is a bool, the type of variable number, and its value is false because effectively 5 is not greater than 5, it is equal. So as you see, even though that we have not directly created the word false, we have created something that is false, a comparison that the code interprets it is false. And here it gives us our result. As I told you, there are many ways to make comparisons. We have the greater symbol, the smaller symbol, and let me show you this with two equal symbols, which stands for a comparison of equality. Here, this would give me a true, because 5 is equal to 5. In this case, 2 plus 3. As you see here, so you don't get confused, there are two ways to use the equal symbol. When you use it alone, just one equal symbol, what you're saying here is, I want this to be equal to this. You're doing an action. You're changing things. You're creating an equality. We use one equal symbol, for example, to load values into variables. But two equal symbols together are actually a comparison value. It's like asking a question, is this equal to this? And it's going to give you a true or false answer. Please review in the introduction to this video where Phil mentioned all comparison options. But if we put greater than or equal to, for example, we are giving both alternatives. We want to ask if 5 is greater than 2 plus 3, or if it is equal to 2 plus 3. And since it is actually equal, we get true, even though we have included the possibility that it is greater. And we also have the possibility to see if they are different from the exclamation point and the equal sign. And since they're not different, they are equal. It tells us the expression is false. Well, there is also a chance to be much clearer. We have directly created here any comparison, and this has given us true or false. You can be much more explicit and create directly the bool function that in parenthesis asks us to put an expression here. Let's see. 5 is greater than 6. We're going to execute it and it's going to tell us that it is false. If we put 5 is less than 6, it's going to tell us that this is true. It's the same as what we did just now. You may be saying, well, we don't need to put bool, but I can explain it to you because we're going to see it in the code and we're going to see how others sometimes include it. When you're reviewing a code, you can find it, and I want you to know that this is exactly the same as putting the expression directly. And if you leave this empty, what you can have is a value of false, right? This also, when you want to generate a false value, you don't want to make an unnecessary comparison. You put bool, and already your variable is going to have the false value. We've also seen throughout the course that you can ask Python if there is a certain value inside a string or inside a dictionary, inside a list or inside any collectible. Well, let's do that so we can see also how to construct a Boolean value. We're going to create a list directly. Let's name it list, and we're going to say that the list has values 1, 2, 3 and 4, okay? And now we're going to create a variable called control, and we're going to tell control to be equal to and to ask 5 if it is in the list. And then we're going to print the type of control, and we're going to print control itself, and we're going to run this. And it gives us back control is a Boolean type value, even though what you have here is a question, and its value is false, because 5 is not found in list. If I had asked here if 5 is not in list, the result would have been true. Well, this is the basics about Booleans, and if you have any doubts, don't hesitate to ask in the questions and Q&A area. Because Booleans, as I told you, are the basis of the logical decisions that our code will make later on. So be sure to do the practical exercises that follow in the next step, and I'm looking forward to the next lecture, so we can move forward with this day that is nearing to its end.
Well, the third day was full of new stuff. We have seen a lot of good things, and it's time to put everything together into practice by creating a perfectly functional program from scratch. Now that you know how to use string method and properties, how to index data sets such as strings, lists, and tuples, and especially now that you know all the data types needed to store anything, you will be able to find a way to program a text parser. The task is as follows. You are going to create a program that first asks the user to enter text. It can be any text, a whole article, a paragraph, a sentence, a poem, whatever you want. Then the program will ask the user to enter 3 random letters. From that moment on, our code is going to process that information and result in 5 different types of analysis. First, how many times each of those letters they have chosen appears. To achieve this, I advise you to store those letters in a list and then use a method of string that allows you to count how many times a substring appears within the string. One thing to keep in mind is that when searching for letters, there can be upper and lower case, and this will affect the result. So to make sure that absolutely all letters are counted, you should pass both the original text and the letters to be searched to lowercase. Second, how many words are in the whole text? To achieve this part, remember that there is a string method that allows us to transform it into a list. And then there is a function that allows us to find out the length of a list. Third, what are the first and last letters of the text? Here we will clearly use indexing. Fourth, the system will show us how the text would look like if we inverted the order of the words. Is there any method that allows us to invert the order of a list? And another one that allows us to join these elements with spaces in between? Fifth and last, the system will tell us if the word Python is inside the text. This part can be a bit complicated to imagine, but I'll give you a hint. You can use Booleans to make your inquiry. and a dictionary to find ways to express your answer. As I always tell you, I don't expect you to know how to do it on your first try, and it's likely that even though you already have the necessary tools, you still might not be able to figure it out on your own, how to combine all of them to achieve our goal. But don't worry, the only thing we ask as your teachers is that you try. You put your head down to the process and try to solve that problem. Succeeding by yourself right now does not matter as much, because once you see how we solved it, you'll have that eureka feeling, that moment where you completely understand it. But if you go straight to the solution right now without trying to figure it out yourself, you won't be learning it as much, and the retention of what you're practicing will not be as great as if you put in the time and effort to try to figure it out right now. All right, so go on, find a good set of music to listen to, and start programming. All right, I told you things could get complicated. So maybe you managed to figure it all out. Maybe your parser only works partially, or maybe you haven't even managed to get it to run. Don't worry. As long as you've suffered a little bit figuring out the code, it is enough to go to the next move and solve it by opening the doors of learning, and you will become more skilled than before. Also, remember, the solution we are going to show you right now is not the only way to do it. If you have achieved it with different code and it works, it is as valid as ours. All right, now let's head over, and Federico is going to show you how to create a text parser in PyCharm.
And now we're in PyCharm ready to create our text parser. Usually when we create a program, we must first think about which variables we're going to need. In the first place of our text parser, we're going to need two main variables. One is going to be the variable text, where I want to store the text generated by the user, and the second variable is going to be the letters that the user is going to enter. We're going to create these two variables now. The variable text is going to be an input because it has something that the user is going to enter. So we're going to put a prompt here that gives some indication of what the user has to do. For example, enter a text of your choice, and this is what the user will understand that he has to do. Then we leave a space with a colon there, and already we have our input. And the letters variable is the place to store the letters that the user chooses, although they are also going to be inputs. First, we're going to generate an empty list, which is where they're going to be stored once the user enters them. Okay, so these would be my initial variables. Now I want to make sure that the text that the user enters is transformed into lowercase, because maybe you remember that is part of this challenge, that the letters that we're going to search in the text could include both upper and lowercase. And one way to do this is to transform all the text into lowercase or uppercase, so that there are no letters of different types. So we're going to call text, which already exists as a variable, but we're going to overwrite it, and we're going to ask text to be equal to text, but applying the lower method that we have here, which means lowercase. Once we do that now, text will be all in lowercase. Okay, let's move on. We're now going to need to ask the user to enter the letters and in turn store them inside the variable letters, which is a list. So let's start with an input. The input is going to say something simple. Enter the first letter, colon, space, and we already have the first command. But we want to store this in a variable. Now, in which variable? Not just any variable, we want it to be stored somewhere in the letters variable, for example, in the first index. So we say letters point append, which is the method to add something to a list. Then we're going to put all this inside the parenthesis, so this input will be immediately added to the letters list as soon as the user confirms his choice. And his choice will be stored in the 0 index, because it will be the first thing to be added. So now we're going to copy this so that this request occurs 3 times. In the second one, we're going to ask for the second letter, and then the third letter. And considering the order in which our code is going to be processed, the first one will go to index 0, the second one to index 1, and the third one to index 2. I hope you follow me so far. Well, we already have the inputs, and we have our text transformed into lowercase. And now I also want to make sure that whatever the user enters as letters will be lowercase, because if the user enters uppercase, we're in trouble. So after this text, we're going to add a dot and we're going to put lower. because technically this is also a string, and therefore what the user enters is going to be transformed into a string. And what we do here is to make sure that this string, no matter if it's upper or lower case, that it's transformed into lowercase. So now we're going to create a line break to create some space between our text. We're going to write, you remember the slash and the n that assures it is an empty line. And the next thing we're going to do is start returning information to the user. So we're going to create a title to present the information about how many times his letters are presented in this text. So that's the first thing we want to inform him. So let's do it in capital letters. Letter repetitions. This is the first thing we have to generate with our code. And if we want to know how many times those letters in the text, we're going to create a variable to store it. Let's call it letter repetition. And we're going to make letter repetition equal to what is in text, but applying the count method, which is the one that allows us to count a specific value. And what value are we going to count first? Well, we're going to count the first of the letters that is inside letters, in the index 0. And this is going to return what there is in the index 0 of the letters list. And it's going to be the first letter that the user entered. This is going to count how many times they're in the text, and here in letter repetition we will store that information. We should have one of these variables for each of the letters entered by the user. So we're going to make this letter repetition 1, letter repetition 2, and letter repetition 3. And this is going to be an index 1, and this is going to be index 2. So we've already calculated these three options. Now we need to inform the user. We can do it with a print that has a literal string. So we're going to put f to begin to compose a sentence that says, for example, we have found the letter. And here we put a key with a reference to letters in the index 0. Then here it will inform you that the letter has been found. We have found the letter X repeated, and here comes the number of times it appears. So we'll make another key with a reference to the variable letter repetition 1, and we complete the sentence with the word times. And it would be great that the letter actually appears in the quotation marks. So we're going to put in single quotation marks here so that the letter that we are going to represent in our string is seen between quotation marks, making our sentence much more clear. We're going to repeat this line twice because we want to say that we have found the next letter, the one that is in index 1, and that the number of times it will be found inside the variable letter repetition 2 and the letter repetition 3, which is the variable that has that information. So do you think we're okay so far? Let's run it and see how we are. Run and run. Let's go to text parser, and here we have enter a text of your choice. And here I'm going to paste a sentence from Jorge Luis Borges, a very talented Argentinian writer of the 20th century. The phrase says, "You are not what you are by what you write, but by what you read." Interesting. Well, let's leave it here. You can put any text you want. Now it asks me to enter the first letter. Okay, I'm going to ask it to look for E, and then it asks me for the second one. And we're going to make it put M, and the third one we're going to put A. Once we hit enter, well, it prints letter repetitions. We have found the letter E repeated 5 times. The M, well, it's never there. We can check, and it seems to be like that. And the letter A appears 7 times. Of course, if you have chosen different letters, or even a different text, you will find different values. So let's move on with the code. Now let's move on to the next task, which asks for the number of words in our text. So we're going to print, let's copy this so that we can paste the break line and sign that says number of words. And how do we do the word count? We're going to need to create a variable called words where we can store this information. And what will words contain? It will contain our text, but we're also going to apply it to method that you will remember, a string method which is called split. That allows us to separate the text into portions. What kind of portions? Well, if we leave this parenthesis empty, it will separate them by the empty spaces. That is to say, it will separate our text in words. And this will create a list. Then words, it will be the list that contains the words of our text. So now I can count how many words are in my list. And for that we're going to create directly the sentence that gives the answer. We're going to make it a literal string that is going to say we have found. And here comes the number of words, inside braces of course, with the length, or len if you remember this function, of the variable words. This is going to give us a quantity. So we have found X words in your text. This should work fine. So let's run it and see if it's working right. We're going to have the same text. We're going to put it in any 3 letters, and here we have the number of words. So we've found 16 words in your text. So far this is working pretty well. So the third part of our challenge was to indicate which letters are the first one and the last one of our text. So we're going to paste in a line break, again, and with a title that says first and last letters. And we're going to create 2 more variables. First letter, which is going to be found using a string method. Let's say text that is 0 index, and that will give us the first letter. And the last letter will be found using the same method, but since we don't know the amount of letters that our text has, what we do is to use the inverse count. So we look for whatever is in the index minus 1. So now we already have the variables we need to be able to print a sentence that is constructed as a literal string that says the initial letter is. So we open some braces and we put the variable first letter and continue the sentence with comma, the final letter is. And also another brace, but this one contains last letter, which is the other variable that contains our information. Since they are letters, let's make sure they are in single quotes, so that our string is not interrupted here. And now this should work. So let's run it again. I'm going to paste my phrase, and let's put in any 3 letters. And down here it tells me first and last letters. The initial letter is Y, so that's right. And the final letter is D, which is right too. Okay, our code is working fine. Notice that this is long but elegant. Now we're going to repaste the headers now to go to the 4th command, which was to get the text reversed, to get the words upside down. So here we're going to put inverted text. And how can we do this? We have a list which is in the words list, which we have here, which has all the words in our text, and we can take advantage of this variable by applying the reverse method. So we're going to do it now writing words, and let's add the reverse method that allows us to reverse its order. But if we print this now, the only thing that we get is a series of words separated by commas and between the brackets of a list. Then we're going to see a list. But I don't want to see a list. I want to see these words organized as if it were a sentence. So let's create a new variable. This one is going to be called inverted text. And we're going to make inverted text equal to an empty space between quotes. Period, and since an empty space is a string, remember? Now we can take advantage of the method we learned today, which is called join. I'm going to join a list of words separated by a space. And where am I going to get the words? Well, from the list words that I've already reversed here. So we can assume that we already have the value that we're looking for. I'm going to check it by printing a sentence that is also a literal string and that says something like, if we order your text backwards, it will say. And here we put the braces to make the variable that's called inverted text, which is the one that contains our answer. And since we want this to appear in quotes, we select it all and put a single quote at the beginning and a single quote at the end, so that it shows up the way we want it to. Will it work? Let's see. Let's run it, and we paste again our text. We choose any 3 letters, and here at the end we have the inverted text. If we order your text backwards, it will say. And here it comes, a pretty weird sentence that has no meaning, but it says, read have you what by but right. You what by are but you are not you. Crazy, huh? And now we're going to create the last of the instructions. And this one may be a little more complicated than the previous ones. So we're going to put the line break here. And we're going to put a title that says, looking for the word Python. Well, I was telling you this might be a little bit more complicated because we still don't really have the necessary elements to be able to do logical tests. That is, if something is found or not. We're going to learn those tools pretty soon, but right now, we have to solve it using what we already have. So this will be somewhat a rudimentary way to do it with the tools we have right now. So as Phil told you in the previous video, he hinted that it would be good to use Booleans and a dictionary. So how? Let me show you. I'm going to do it in the following way. First I'm going to create a variable called isPython, which is the one that will store the information about whether or not the word Python is found in the text. So how do I do this? Remember, I type the word I want to search for, Python, and ask it if it is in the text. Then, is_Python will contain the answer to this question, which is in this case, in the case of the text I included, it will be false because Borges did not know Python. Well, now I want to know that Python is found or not. And I can get the information as a value, true or false. What I need now is to be able to incorporate that word, true or false, to a literal string. But the problem is that these words will be capitalized, and I need them in lowercase to be part of my sentence. Actually, I'm going to change them so that in the other word they will make my sentence more readable. So I'm going to create a dictionary. I'm going to type dic here, and the dictionary, it will have only 2 pairs of elements. A key that's called true, and that's associated with the value was, all lowercase. And then we're going to create a second element for this dictionary that's going to have the key false, and we're going to associate it with a string that says was not. So now I can make some kind of logical comparison, where we're going to write a print that is also a literal string that says the word Python. And here we have to say was found or was not found. And we have those phrases as values in our dictionary. So how am I going to locate them? Well, I'm going to make a call. To whom? To isPython, because isPython has the word true or false, since the search has been done. And where am I going to look for the word true or false? Well, in my dictionary. So let's put all of this in curly brackets and write dic here. So what I'm looking for then is whatever is in the dictionary as a value for the key true or false. That is, it is going to tell me was or was not. So I really hope you follow me at this moment. If not, please pause the video and view this logic carefully. So we've completed the sentence. The word Python was or was not found in the text. Did it work? Did we get it right? Did we get it more or less right? We're going to run it one last time. So we're going to type the same text. We're going to type any 3 letters, and already all of this we've checked and it's working fine. So now we have looking for the word Python. The word Python was not found in the text. And the last check we're going to do is run it again. So here we're going to paste in the text now, and I'm going to purposely put Python here, even though it doesn't make sense. We're going to hit enter. We put in any 3 letters, and now we see that at the end of the word Python, it was found in the text, so it worked. So our next parser is now functional, and can be used by anyone who is interested in using this little program. Please forgive the length of this lecture, but we needed some extra time to deploy everything we set out today.